this topic, and by the time others join, we would have already reached a place where something that we have to discuss in today's lecture is what we have to. We will just begin with that after that, right? Awesome. So, in the last class, guys, if you all recall, what we were discussing was the design for FB Messenger, right? And in FB Messenger design discussion, towards the end of the entire discussion, we were trying to see that the workload pattern for a messenger system like FB Messenger happens to be like a read plus write heavy workload, right? I hope everyone is on the same page with whatever I have said, that the messenger system we were trying to build was having a read plus write heavy workload. And we paused ourselves on a place where we wanted to decide the database for the same, right? And I happen to mention that typically when you're trying to make a choice for database, at least when the choices are being made in a company, when you're actually working on something or building a production grade application, it's an iterative process that goes on for weeks, if not months, before you actually drill down on one database system, because that is a system you will have to run in production for your customers for a long period of time. So you don't take that decision in minutes or in a few days, right? Typically you have to stick with it for a long period of time. So in actuality, in real life, it takes a lot of time for you to figure out which database to choose. That being said, typically, but when you're appearing for interviews, you don't have all the days or hours to give those interviews, right? So you typically have some 2-3 minutes in which you have to spit out some things, some reasonings for any problem statement that comes in front of you as to what database you would probably go after, right? So for that, let's try to discuss, let's try to have a brief conversation around from the perspective of a messenger system. So in the last class, I told you that no database is optimized for heavy writes as well as heavy reads. Like, I mean, you can say that you have databases which have good performance on reads and writes as well, but typically based on the data structures that these databases choose or to implement behind the scenes, they are either write optimized or they are either read optimized or they are either write optimized, right? And in the last class we tried to see what if this read plus write heaviness that we have in our problem, let's try to reduce one of the components, and once we can reduce, let's say, the read heaviness of our system, then we can choose a database that is going to be write heavy. Or let's try to reduce the write heaviness from our system, and then the database we can choose which can be a read heavy system. We tried to take a look at the case 2 where we tried to reduce the writes, right? And then we thought, let's batch these writes, either batching or let's try to do it asynchronously with the help of a message queue. And we'll take a look at this how at message queue in depth today. Okay, so we took a look very quickly at these two ways, but we realized that one of the non-functional requirements, no Mohit, you did not miss anything. I'm just trying to cover something that was covered in the last lecture. There's just a few minutes of discussion that I have to do with respect to the database choice, and after that we'll start afresh, which has no prerequisites. So just bear with me for the first 10-15 minutes, and then it will be all fine. I think you messaged on the group that you did not attend the last lecture. Don't worry, this is just a 10-15 minutes discussion. Okay, awesome. So what I'm trying to say is that in the last lecture, we tried to discuss, can we reduce the write heaviness from our system and hence choose a database which is going to be read heavy. Okay. And then we tried to see how can we actually reduce the writes. There were two ways. One way was a batching way, and the other one was in performing these writes in an asynchronous way. Correct. But we realized what was the problem, guys? What was the problem for going with any one of these approaches? Can you guys type it quickly in the chat section? Think of it like an interview itself, right? Think of this exactly like an interview. This is how people would go ahead and drill you in the interview. Yes, batching takes a hit at consistency, right? It will take some time for the batch to be actually flushed into your cache or into your actual database, and hence the people who want to get access to these messages at low latency will not be able to get it, right? So we need some way with which we can do this with extreme low latency, right? With low latency, and hence reducing the writes was not really the optimal way. So then we started to take a look at how we can reduce the reads, and can you quickly write it? How can we reduce the reads typically that are happening on our database? What is at least one thing that should come to your mind when we want to reduce the reads that are happening on our database? Caching, right? So we can employ the technique of caching. What we can do anytime someone is sending a message, we can cache it in front of the database itself, so that our read calls do not have to go all the way to the database, and they can be served by the caching layer itself, which Hey guys, can you hear me? Can you see me and hear me? Oh, I'm sorry, I was saying something, but you're not able to hear it. All right, fine, awesome. I'll just share my screen again. Can you see my screen right now? Please give me a +1. What have I written just on the screen? Okay, I hope you guys can see the screen in real time, right? Okay, fine, awesome. What I was asking guys when this entire voice thing happened, I was trying to ask what is this technique called where you write something to the cache and you also go ahead and perform a write to the database as well in order for you to have latest things in your cache. What is this technique called? Write through cache. Exactly. This is called a write through cache technique, right? Which is what we discussed in the last class. Now, we want to discuss now obviously by virtue of this activity you would have seen that your read requests are being served by your caching layer itself, correct? And these read requests are not going all the way to your database, but they will go in case there is a cache miss, right? In case there is a cache miss, those read requests will actually go all the way to the database now, right? But that will be very less, but the percentage of read requests that will land on your database will be very less. And hence, we can make a conclusion that let's choose a database, let's choose a DB that is highly optimized for what things? Heavy write workload, and consistency as well, right? Because we want consistency in our architecture. This is something that we've already discussed in the last class in our non-functional requirements for our system, right? Now, here comes a decision that you have to decide between choosing, let's say, a database that is based on, let's say, a B tree kind of a data structure, right? Or whether you choose something that is based on the LSM tree kind of a data structure, which we discussed in last to last lecture. Okay. Now, typically B plus tree data structures, B or B plus tree kinds of data structure, these are highly optimized for read heavy systems. Okay, these are highly optimized for read heavy systems because of the hierarchical tree structure that they maintain on disk, right? And hence the read queries, they are typically served in logarithmic time, right? Logarithmic with respect to the height of the tree, or no, not the height of the tree, I'm sorry, the number of nodes also. Log to the number of nodes. No, I think it's height only. I think it is height only. Yeah, it is height only. Right? So you only have to traverse through the tree and you make decisions because there's a set order. And I think someone had shared one lecture by Anshuman on our WhatsApp group as well, which in depth explains how B trees maintain data for MySQL databases or relational databases. So typically these databases are optimized for read heavy workloads, right? That is the first point you should understand. The second point you should understand, at least about MySQL kinds of databases, is the fact that these databases are heavily used for things that for entities that have some sort of a relational nature between them, relational nature between the entities that you have defined. So if you are designing, let's say, a system where you have some users, and let's say the users end up having some profiles, and then profiles can be linked with, let us say, some Facebook pages, right? Let's say we are designing FB only, right? So you have some users existing on the platform, and then you have, let us say, certain profiles over there. Profiles, there can be some pages also that can be associated with some pages. So in this case, you end up using some concept of foreign key in order to define relation between different entities of your system. And in that case, it makes a lot of sense from the data modeling point of view for you to choose a relational database. Whereas in our case, in messaging, we just have raw messages and some metadata that is associated with it. I hope you all understand what is the meaning of metadata, which is not the actual content of the message. Instead, it is the ID, the message ID, the timestamp at which it was sent, the sender ID, the conversation ID, these kinds of things. These are called the metadata. And these are set patterns. You're not going to be defining some relations. You're not going to be joining messages with, let us say, a different column or a different table altogether, right? So because of that, it makes a lot of sense for you to not prioritize B plus tree or B tree kind of a model, which is like a MySQL kind of a storage model for your data, at least from the data modeling point of view. Now, from the workload point of view, your workload is extremely heavy on the write front. right? Because we have reduced the reads by usage of a cache, and hence our system is going to be extremely write heavy. Since our system is going to be extremely write heavy, the data structure which we discussed in last to last class, which is the concept of LSM tree, which internally uses a wall or a commit log, right? The writes are extremely fast. The writes are extremely fast. And if you were to use this in a database which has some sort of a multi-master replication concept, multi-master replication, wherein we ended up discussing the concept of R and W, where you can tune R and W to ensure that the data that you're writing to your cluster is highly consistent. Right? I hope you guys recall the multi-master replication concept. Please give me a +1, guys, if you recall what the multi-master replication concept was. Right? Essentially, R means at least R machines from your replication factor number of shards should receive this write successfully in order for you to unblock your client. I'm sorry, the reads. And W also happens to be the same. When you're serving a write request, you have to write it to at least W nodes, W shards amongst your X, which whatever is the replication factor, and only after that do you unblock your client, right? So with this, you can actually tune your database to be highly consistent, moderately consistent, absolutely low consistent, any one of these things, right? So and obviously, since it happens to give you a choice to make your system highly consistent, you can tune these parameters and make your system very consistent. That is one thing. And the latency kind of non-functional requirement that we had, that we should have a very low latency kind of a system, that thing is also being solved by the commit log kind of a data structure. So for the problem statement that we are discussing right now, this LSM tree kind of a storage engine happens to be a very good candidate. Now in LSM tree kind of a database, there are some NoSQL databases that fall into it, right? Things like DocumentDB, or you have some things like a column family databases, right? Typically DocDB kind of databases are used for highly unstructured kind of a data, where you today do not know what are the other fields that can be added into your schema. For example, if you're building something like an e-commerce catalog, for example, for every product, you have to list a few things, right? You can end up adding more and more fields for different kinds of products that would have been listed, let's say today, as opposed to products that were listed, let's say 1 year back. Because let's say Flipkart decides that, okay, fine, we want to give 10 more features that the user should be able to see once a product is listed onto the screen, right? But we don't want those features to be backported to the previous products that existed in our catalog, right? So for the new products, you can have, let's say, 10 fields in the JSON representation of the product. But the older products that existed, let's say 1 year back, they can have maybe 2-3 fields. So that happens to be an example of a highly unstructured kind of a data. Those kinds of models, those kinds of data models are typically very ideal for usage with a DocDB kind of a system. And things where you have some sort of a structure with respect to what you want to store, those happens to be very good, candidates for a column family database, right? Why did I say column family database? Because column family databases like Cassandra or HBase, let's say, these people also have the flexibility of following this multi-master replication in order to have a highly consistent nature of the writes that are being performed onto the system, right? Because of that, things like Cassandra or HBase can be ideal choices for you to figure out what is going to be the ideal database for the heavy write workload that we have for our system. I can share in depth. I shared in depth a very nice documentation of Cassandra, which can help you understand precisely how the data is stored in Cassandra, what is like the low level data structures that are used, which we already have discussed, SS tables, mem tables, and the high level data structures, which you as a user can map your data into, which you can understand. For example, MySQL has tables and all. Similar to that, column family databases also have a concept of multiple families of columns, and then within a family, you can define some sorts of a tables, etc. And I believe Tarun would have discussed a little bit about this in the NoSQL versus SQL kind of a lecture that we had, right? But if some of you still have any doubts on this, I can share a very good read on how the data is stored in Cassandra, but that happens to be a very surfacial thing. You can spend your own time to read about it, and if things are not clear, we can definitely discuss it in one of our doubt session classes, either in the next lecture, or you can definitely post it on the WhatsApp group. I'll make sure that I cover it in the next class, right? But typically, I hope you guys can understand why we discarded DocDB and why we thought of choosing something like a column family data store. Because column family data stores helps you define set columns for your data, and hence you are using the fact that data model is having some set forms of some set columns in its structure, which is a good quality for a column family data store. And secondly, we have extremely high write workload for our system, which is also a very good candidate for something like a column family data store, which is why we ended up choosing a system like HBase or Cassandra. Facebook typically stores its system. I think it started with Cassandra, then moved to HBase, then moved to back to a data store that is again something like a MySQL storage kind of a data structure. So typically, depending on the life cycle of the product, the database also keeps changing. But if you have to think about it in a short span of time, this is at least how you can go ahead and think about it. Which one out of these keeps the latest data on the top? Amit, you're saying which one of these keeps the latest data on the top, or both? It depends on what sorting key you have chosen. I don't understand what you mean by top. What do you mean by top? Not, I didn't understand this question. Please type it. Okay. Hey, Amit, I've unmuted you.
So in the NoSQL class, you told us that I don't remember exactly, but you told us that one of the DB keeps the latest data always on the like top. So
Oh,
something
memtable.
like
We talked about that, keeping the data in warm cache, something like a memtable, the latest data, and then flushing the older data into SS tables. Is that
no,
what you're
no.
talking
I think you were telling it was in SQL versus NoSQL class or some other class. I don't exactly remember, but you told us that one of the maybe column family or the document DB, one of
about?
them keeps the latest data always on top, so we
Yeah.
can
Okay.
like very easily extract the
Uh-huh.
latest data.
Okay. I got your point. I think so. I didn't take that lecture. It was Tarun who took that lecture, but the definition of top is not very clear to me. I can read through it. I can go through the recording where he mentioned that and explain it in the next class. But I don't exactly understand what you mean by top because I didn't say that myself, which is I'm not able to understand. But I can help you with that in the next lecture. I'll take a look at what he meant with that and I can explain it.
Okay.
Okay. All right. Awesome. Cool. All right, guys. So this was precisely what I wanted to discuss, at least with respect to the database choice for a messenger kind of a system. And uh, if there is, yeah, she's saying it's like stored in sorted order. Yeah. So if you mean by storing data in sorted order, then yeah. Databases like NoSQL, like Cassandra and all, they give you ways in which you can sort the data in a specific partition in a specific column, right? Those facilities are available over there. But if that is what you meant by top, then yes, this is good, right? Also, since these are databases that are highly good for making time-based queries as well, time range-based queries, which is also something that you end up using for systems like messengers, right? You want to get the recent messages for someone. So databases that can actually query on the basis of time as well. Those happen to be very good, right? So time series DB, there are different DBs that are optimized for that, but Cassandra also happens to be a very good candidate for it. Awesome. So guys, yeah, this is what at least I wanted to cover from the last lecture with respect to the choice of database. If at least the discussion that we have had with respect to this, when you want to decide a database, think about the data modeling. Okay, think about the workload pattern, right? Think about the availability slash consistency needs, and then eventually come down to one database that you want to choose. And by no ways am I saying the database that you will choose will be the ideal database. There is nothing called as an ideal, at least in system design modules or in HLD things. Okay. For example, if you want to choose for a highly available database, MySQL databases happen to be very highly available, right? Because you have like masters and slaves, and immediately you can promote a slave to become a master. So it's a highly available database, but it is not going to be consistent because there is replication that is happening from your master all the way to your slave, right? So Kunal is asking, so for messenger system, we will choose SQL. No, Kunal, all that I explained till now, I wanted to explain to you that no, SQL does not happen to be a good choice for us to choose a database for at least from a messenger kind of a system, right? Because in messenger, we don't want to prioritize availability. We want to prioritize consistency. Make sure to go through a little bit. So if you just joined the previous part of our today's lecture, you'll be able to understand, like I explained in detail, why we should be going ahead with something that is based out of an LSTM tree kind of a model, right? Awesome. So guys, please give me a +1 if this simple thought process that I've explained to you with respect to choosing a database makes sense to you. If that is fine, then we can get started with the agenda for today's lecture. All right. So I hope brief thing is clear. And also, guys, this is a highly iterative process for you to understand which database to choose for a specific use case, right? So don't over-index yourself to understand key. In one lecture, you should be able to understand precisely how to choose a database for any problem that is thrown at you. It will come with time. That is the only solution that is the only thing I can say to you. Okay, awesome. But these three things, you should try to think about these when you're trying to make a choice for your database, right? Awesome. So let's get started with the things that we wanted to discuss, at least for today, right? And the first topic that I want to discuss is the technology called Zookeeper, right? This is a technology that if you have not heard about it, or if you've heard about it, does not matter. We'll take it from absolutely from the scratch. In fact, we'll try to see the problem that it ends up solving, and then we'll see how it solves that problem and what its internal architecture is. Okay, so this is how we'll take a look at Zookeeper. Don't worry if you've not heard about it; it's absolutely fine, right? So one of the things that I just mentioned, at least about the MySQL database as well, and we have been discussing again and again, but we never actually delved into the depth of it, was the fact that let's say you have a master database for a MySQL database, right? Let's say you have a MySQL cluster, and in the MySQL cluster you have, let us say, 4 shards. Okay, let us say you have 4 shards, and every shard has a master, and then there is a replication for it as well. Okay, so there happens to be a slave. Yeah, Mohit, Zookeeper has been removed from recent Kafka updates. But let's try to first of all understand what Zookeeper what problem it actually solves, and then towards Kafka we'll take a look at how Kafka does this problem, right? Solves this slave, right? Awesome. I hope you guys can understand, and that in this diagram that I have drawn, these are the shards, and these happen to be the replicas of this specific master, right? Please give me a plus sign if this thing makes sense to you. That these are the replicas, and these are the shards, and these are the replicas of them, right? Awesome. Now we ended up discussing a lot of times in our lectures that, okay, fine, all the writes we are going to be sending to the master database. How will we be sending these writes to the master database? How will the client, let us say it is the app server, how will the app server know that my writes have to actually go to a master database? We didn't discuss that. Like, how will the app server know the IP address and the port to which it should be sending a write query so that it lands on the master database? We just said, okay, fine, we'll send the writes over there. And the second scenario, what if one of these masters was to crash? What if a master were to crash? In that case, we ended up discussing that how one of these slaves can be elected as the new leader or the new master for this entire cluster, and these writes will then be sent, instead of to this master, we will start sending it, let us say, all the way to a slave which will be promoted to a master. Let us say this slave was promoted to become a master. So all our writes, instead of going to this master database, will start going to this slave database, which now has been promoted to become a master. But this information, how does my write query from the application server know that my writes have to be served to this slave database now? We did not discuss that. Is everyone on the same page? Like the problem that I'm trying to present over here, that we have not discussed this concept as to what happens if a slave was to be promoted to a new leader. In that case, how will we ensure, by we I mean any system that is wanting to perform writes to this specific master database, how will it know that it now needs to send the writes to the master database? We have not discussed that problem right now. Secondly, what if there is a master database, and let's say there are a bunch of slave databases, right? And let's say each of these slave databases, let's call it S1, S2, S3. Let us say this is in India. Let's say this is in North America. Let's say this is in South America. What if, and guys, by the way, in a typical master slave architecture, what kind of requests do we serve by the slaves? Can you quickly type it in the chat? What kind of requests do we serve from the slave databases? No, I'm not asking for +1. Just can you write? Yeah, exactly, reads. So the reads are served by the slave databases. Now, what is a problem? What is one problem that can arise if you're sending, let's say, reads blindly to these slave databases? Can one of you mention what kind of a problem can happen if you're blindly sending the reads? Yeah, inconsistency can happen, stale data can happen, but what is a bigger problem? Even bigger problem. What if this entire slave database was down? What if this entire slave database was down, and in that case, all the read requests that are being served by, let's say, this South America wala shard of your slave of your database cluster, those queries will not get the data, right? So you need some way, the client who is sending the read requests, it needs some way to figure out which all of these slave databases are actually healthy. By healthy, I mean which all of these places actually are working fine. So till now we have not discussed how that thing happens, right? So Narendra is saying failover, but yeah, how do you even determine that something like a failover needs to be done? Failover basically means promoting a slave thing to become a master, or maybe if you're sending your read request to a database which has actually failed, now you, instead of sending it to that, you send your request to the other databases. How do you know this? What is the entity that is going to solve for these things? This is something that we have not discussed so far. Yeah, health check, yeah, health beat. So that kind of thing is something that we have not yet taken a look at. These kinds of issues, the problems that I have just mentioned in front of you, these are the kinds of problems that this technology, which is called as Zookeeper, helps us to solve. And now we'll try to take a look at the brute force. Amrita is asking, do you mean disaster recovery? So Amrita, you can think of it in some ways like a disaster recovery, but disaster recovery typically has a lot of other things as well. If one of the, let's say, database goes down, then you have to replicate the data from that place to the other places, right? So that the clients who are being served from your failed database can now access the same data in another database. So disaster recovery is a very big topic, right? We're trying to specifically right now discuss the problem of service discovery. But what do I mean by service discovery? Which means that, let us say, this is the client who was sending the read requests, and the read requests were being sent to, let us say, these three slave databases, S1, S2, and S3. Some of them were going to S1, some of them to S2, some of them to S3. But then what happened is, let us say this died. If this died, where should we send these read requests? That is the problem, right? So service discovery is the problem that we're trying to solve. Service discovery and the health check thing as well. Health check or health beat, heartbeat thing. That's also, some people mention it like that. Is the problem, guys, clear to you? Which is going to help us, which is basically the Zookeeper technology going to help us solve it? Is this, is the problem statement clear to you guys? Please give me a +1 if the problem statement is clear to you. Is there anyone who has not understood the problem we are trying to solve? I hope everyone is clear. Is it similar to Eureka from Netflix? Manchu, I don't know what Eureka is. Let me just quickly see. Eureka, Netflix, service registry for resilient. Yeah, I think in some ways it is like what the technology that we want to discuss, but I would not say a very authoritative word right now. But if any one of you has worked with Kubernetes, so in Kubernetes there is this technology called HCD, right? Which is basically a state store which is used for managing all the state of your entire cluster, right? That is very similar to this. That is very similar to what a Zookeeper thing does. Okay. Yeah, I'm not sure about Argo CD either. I've worked with Kubernetes a little bit with Zookeeper, which is why I know. So load balancer does the same as service discovery. Yes, Mukul. So load balancer does the thing of forwarding your request to all of these instances which are registered with the load balancer. But how would the load balancer even know that this new server that you want to register with it, is this alive or not, right? Or what if this master slave kind of thing happens, where you now want to send your write request now to a different slave? Those things cannot be inherently done by load balancer. Either you need to build your own load balancer, or you need to have a technology like Zookeeper, which is what we want to discuss today. Okay, awesome. So now let's try to see a naive approach. Let's try to see a naive approach to design for a Zookeeper, right? We try to see from scratch, if we were to, let us say, solve the same problem, right? Let us say we were to solve the same problem which basically the Zookeeper is doing, is supposed to do. Let's try to see how would we go about essentially doing it, right? Okay, so let us say there is an application server which has to eventually go ahead and perform the read and write requests to this MySQL cluster. Okay, now let us say this is the master, and this happens to be, let us say, two slaves of it, right? What you can do, how can you solve this problem? What you can do, you can have some sort of a dedicated machine, okay? And this dedicated machine can solve the problem for us. What problem? Your app server, just before it is going to perform a write operation, it will ask the dedicated machine where to send the writes, right? And the dedicated machine will keep talking with this cluster to figure out whether the master database which is the database server which is responsible for getting the right request, is it healthy or not? If it is healthy, the dedicated machine will serve the IP address of the master all the way to your app server, and then your app server can go ahead and start performing the write requests to the master database. Is this point clear to you? Is this one point at least clear to you, that how the writes will happen in this case? Right? I hope this point is clear to everyone who is present in the class. Please, guys, give me a +1 if this point makes sense to you. Awesome. Now, let's say the slave, let us say the master were to die away. What will happen in that case? Now, one of the slave needs to be promoted to become the new master. How can we do that? This dedicated machine can keep a watch, can get some heartbeats from this master machine. If, let's say, did not get those heartbeats for a certain period of time, the dedicated machine will immediately decide that, hey, the master machine has died, and now we need one other slave machine to be promoted to become a master. And hence, this dedicated machine will convey this information to these slave databases, and you need to be running some sort of a code over here. You need to be running some sort of an application code over here, right? Which, once it gets a request that leader election needs to be performed, let us say you call an API which has leader election. Let us say this leader election query was sent to both of these slave databases. Then the slave databases will run some algorithm within them, and eventually one of these slaves will be chosen to become the master. And once one of these slaves has been chosen to become the master, they will send this response that, hey, I have been chosen as the master for this cluster now. And then this dedicated machine will send that to this information to the app server, and app server will now send the write request to the new master for this entire cluster. Correct? And how will the leader election happen? They will try to communicate within them, and they will actually try to see which has the most latest reads on the basis of the commit log or the wall that we have discussed previously. Animesh, you are correct. Right? So in this way, a dedicated machine can essentially solve this problem for us. Does this point make sense, guys? Does this brute force solution of what we want to do with Zookeeper, does this make sense to you? How we have tried to solve the problem of heartbeats and the problem of service discovery. Basically, we are relying on a dedicated machine to help us get this information, right? Shivam asking, is application code in front of every slave? Yes, Shivam, it will have to be in front of every slave as well, right? Why will it not be on every slave? It will be there, right? Because dedicated machine. So if someone says, keep this box in any system design thing, okay, someone says this box is talking to this box. What does it mean? What does it mean? It means that there is some API call that is being performed by some application code that is running over here, and there is some application code over here which is intercepting those API calls and running some logic. So there needs to be an application code in front of every slave. Is this point clear to the person who asked me this question? Who was it? Shivam. Is this point clear to you, Shivam? That we need some application code to intercept these API calls and to perform whatever the logic was. Amrita is asking, what is the logic / algo of leader election? So Amrita, this is I have already discussed in the master slave architecture, but typically one of the ways is to ensure whichever has the most latest writes from your masters, replicated writes, that should be promoted to become the new master now, because it will have the most recent state of your entire MySQL database, right? Awesome. Isn't this similar to K8s? Yes, Basil, this is very similar to Kubernetes, right? Kubernetes mein HCD also does something similar. It basically calls it controllers, right? The controllers that Kubernetes uses, that is the concept. It's just a nomenclature difference. Try to focus on the problem that we're trying to solve, and it's very good that you're able to relate it with a system that you've probably used or heard of before, right? So yeah, it is exactly same to Kubernetes, right? But now, in this architecture that we have discussed over here, what is the drawback? What is the drawback over here? What is the drawback of this architecture that we have just discussed? Can you guys think about a drawback of this architecture that we have just discussed? Please type it in the chat section. Whatever you guys feel is the drawback of the system. Yeah, one happens to be the single point of failure, right? What if the dedicated machine fails? Correct. Multiple calls to check alive or not. Well, Shri, it's very difficult for you to figure out in one call whether the entity on the other side is healthy or not, right? For example, if you call your friend just once in 10 years and he says, I'm okay, you won't assume that they will be fine for the entire 10 years, right? You keep checking on your friends and family members. So there is potentially no way for you to figure out whether something is alive or not, except making regular calls. So that is something that we cannot live without, right? But single point of failure, someone is saying dedicated machine can die. Any other thing that comes to your mind? Can you see that every time the app server needs to send a write request to the master, it first needs to consult the dedicated machine. Why? because it is possible that the master machine could have died. So the write request that I'm sending, the app server has no clue whether the slave has been promoted to become the new master. So the app server has to incessantly, very frequently, before sending any write to the master database, first of all, it has to send to the dedicated machine. And only after that, once it gets the value, it will send it to the master. Let me write these points down, right? So the first drawback is the single point of failure. I hope everyone is clear on the single point of failure thing, right? The second one is for every read / write request, the app server has to consult the dedicated machine for the IP address of healthy slave and master. Are these two drawbacks clear to everyone who is in the class right now? Are these two drawbacks clear to everyone? Nikhil is asking what will happen in case if dedicated machine makes request and got the acknowledgement like master is up, but when it informed to app server, the master DB went down. So in that case, okay, fine. That's a good point, Nikhil. So in that case, you can have either you keep updating either you keep sending the heartbeats from the master all the way to your dedicated machine at a very frequent rate, right? That is one way. And the second way is your app server, once it sends the request all the way to your master, the write request, it will get some sort of a 5xx, right? Or service unavailable, right? Yeah, some sort of a 503 kind of an error. In that case, your app server will have to consult again to the dedicated machine. But it is a correct point that this will happen some latency. This will introduce some latency in our system, and this is not happening this is happening on an eventual basis. When the problem arises, only then we are trying to solve this problem, right? So yes, this is also a definite flaw of this point, and it is introduced because of this extra hop that we have to do all the way to this dedicated machine. The point that you are saying is a logical follow-up of this point that I've mentioned over here, right? Dedicated machine can update the server only when there is a change. Yeah. I mean, yeah, that is one way in which we can solve this problem with. You're absolutely on point. Dedicated machine can notify app server only if there is a change. Yes, Shri, yes. You guys are coming to the solution. Very nice. That is awesome. But for now, is everyone who is present on the class clear with the drawbacks? If you're clear with the drawbacks only, then you will be able to appreciate the architecture of Zookeeper, guys. And most of you have already mentioned what exactly Zookeeper does over here without even knowing that you have mentioned it. Is everyone clear with the problems that we have discussed so far? Is there anyone who has not understood this? Please let me know. I will explain it again. Just type no in the chat. I will explain it again if it is not clear. Okay, I'm assuming that the problem statement is clear and that the brute force solution is also clear to everyone who is right now in the class, right? Now we'll spend some time to understand how Zookeeper helps to solve this, right? But before that, let us first of all try to spend some time to figure out how does Zookeeper actually store this information that we have over here, right? Like this information about, hey, this is a master, and then this master has some IP address associated with it, etc. How does the Zookeeper even store this information within it, right? So before that, let me just write a quick definition of Zookeeper, right? Zookeeper essentially happens to be a system, distributed system rather. Let me call it that way. A distributed system that helps to do two things. Number one, coordinate state between different systems. Okay. And secondly, it also helps us maintain configurations of the system that it is managing, right? I hope these two English statements are clear to everyone. Key number one, it helps us coordinate the state between the different systems. How it does so, we'll take a look at that. And the second statement, which is to maintain some configurations of the system that it is managing, right? These are the two responsibilities of Zookeeper, right? And because of the first thing, like coordination of the state between different systems, it is also called something like an orchestrator, right? Some people call it as an orchestrator as well. So if you hear these English terms, don't get confused. They're just trying to say that there is some person who is trying to manage some system and some state about a system, right? And rather, it will be better to call this as metadata about the system. Why did I say metadata? Because Zookeeper is not actually storing the data of your, let's say, the MySQL cluster that it will eventually manage, right? Let us say this is the MySQL cluster which it is eventually going to manage. It is not storing the data of the database itself, but it is storing rather the metadata. By metadata, I mean whether it is alive or not, whether what is the IP address of this of a specific database server or not, what is the port on which you should be sending your write and read queries, right? These kinds of informations can be stored in the Zookeeper, right? So hence I called it metadata. Right? I hope this point is clear to everyone. Right? It is not storing animation, the schema of the entire database. Right? Schema things are not stored in Zookeeper. All the things that are stored in the Zookeeper are things that are either helpful for some state management across when there's some sort of a lead election thing or something, or during a failover or during health check, those kinds of things, and configurations. Right? These are the two kinds of things which we end up storing in a Zookeeper. Right? Now let's try to see the data structure. Let's try to see the data structure followed by a Zookeeper machine. Okay, and right now we're just trying to see how one Zookeeper machine, let's say we have one Zookeeper machine. Okay, there can be multiple Zookeeper machines that you can end up having in your cluster, right? But whatever is going to happen on one machine, we'll try to take a we'll try to zoom out, zoom in, no, zoom out, whatever you call it, right? We'll try to zoom and we'll try to see how things are stored in one Zookeeper machine only. Okay, so typically a Zookeeper follows a file system kind of a data storage. File system. So just the way you have something like what do you call it as directories, and then within the directories you end up having multiple, let's say, subdirectories, right? And then within the subdirectories you can have then files, right? Or you can have multiple levels of directories as well, right? So this is exactly the way in which Zookeeper ends up storing the data for your cluster that it is managing, right? Let me explain this to you with an example. Let's consider that there is this master data. Okay, fine. Let me explain it to you with this example, right? Let us say that there are multiple shards in your entire database cluster, and then each shard has, let's say, 2 replicas, right? Let's say that is the case for everyone, right? How will this information be actually stored on the Zookeeper? Can you please repeat the last 2 minutes? Shri is asking. Hey Shri, so Shri, I mentioned that the data structure, we are trying to see the data structure that is followed by a Zookeeper. Basically, how is the Zookeeper going to store this metadata about the system that it is managing internally? This is what we are trying to discuss. And Zookeeper can be entire cluster as well. There can be multiple Zookeeper machines because of replication, and what if one Zookeeper machine fails and whatnot, right? So we are not looking at that complication right now. We are just trying to see how the data is going to be stored on one single Zookeeper machine, right? We're just trying to zoom in and try to see how something is going to look like inside one Zookeeper machine. And what I've discussed after that is that typically the data model that is followed by a Zookeeper kind of a system is a file system kind of a structure, right? So you have some directories, then within the directories you can have subdirectories. Within the subdirectories you can have a bunch of other subdirectories, or you can have some files that actually store some data. This is essentially the data model that is stored. Let me explain it to you with an example. So let us say these are different shards in, let us say there is a payment service for your system that you're building, and then this payment service has, let's say, a bunch of these databases behind it, right? And let's say this is shard 1, shard 2, shard 3, all the way to, let us say, this is the shard 37, let's say, hypothetically. Okay, how will this data about this cluster be stored in Zookeeper? Let's try to see that. Okay, so typically you have the root of your entire file system, right? Inside of that there will be a directory that you can call as payment service, right? Then inside of this directory you will have some information about, let's say, shard 1, shard 2, or in fact before that, let's say there'll be another directory called, let's say, database, because your payment service can also be using some cache. So if it was using, let us say, some cache as well, let's say it is using some cache also, and cache also has some replicas, let us say, right? So you will have a different folder within payment service for a cache. Okay, but let us say we are focused only on database. So within the database, then there can be multiple shards that you can end up dealing with, right? So what you can do inside of the database, you can have now another directory. You can call this directory as shard 37. There'll be different directories for each individual shard. There'll be one for shard 1, for shard 2, so on and so forth. Eventually you land on shard 37. And what are these things, guys? These are basically directories or folders, as you may want to call it, right? And inside the shard 37, right, we are then going to have some files. What will these files actually be? This one file, you can call it as master IP, and then there can be another file that you can call as master, let's say, port. Then you can have another file, let's call it slave _1 _IP. Then let's say slave underscore one underscore port, so on and so forth, right? So these things are files that are actually storing some data within them. What is that data? The metadata about the cluster that Zookeeper is managing, correct? And what are these things? These are basically folders or directories. So can you see that there is a hierarchical nature? Let me type it. Sorry, let me write it. There is a hierarchical nature in nature of storage in Zookeeper. Why is there is a hierarchical structure? Because one Zookeeper cluster can manage information for all the different systems that your entire system has, right? Let's say you were to have a cache. So let's say there's a payment server. Let's say this is the root. Okay, there's a root of the file system, and then there's, let's say, something about a payment service, right? And by similar to payment service, you can have other services as well. Let us say there is an authentication service as well. So then there can be something like an authentication service folder inside of, let's say, a payment service. Then there is, let us say, some cache. Within the cache, you can then basically end up having a bunch of, let us say, information about the cache. You can have, let us say, the storage about the shard, whatever. Let's call it shard one, and then within shard one, you can have master for that cache, then for the replica of that cache, right? And then instead of the cache, you can also end up having some other information. Maybe you have some information for, let us say, some distributed lock, right? Let's say you want to have some distributed locking kind of a technology. Whatever technology you want to store, whatever cluster you want to manage, you can map that in this hierarchical structure with the help of the file system that is given to you by the Zookeeper, right? So essentially, it is at the end of the day trying to store data of your exact clusters in files, but the structure in which it stores it is similar to that of a file system kind of a model. Is this data structure, at least just the way Zookeeper stores the data, is this thing getting clear to you? So Zookeeper is kind of doing orchestration and saving data. Yes, Amrita. So it is also saying the, okay, Prince, let me explain it to you once again. Okay. For example, let us say this is a database. Okay. This is, let's say, the master database, and the master database, let us say, has two slaves, S1 and S2. Right now, what is the information that we want to store? I mentioned that it is the metadata. What is going to be there in the metadata about a master database? You want to store the IP address for it, like, because you want to connect to it eventually. So how do you store this metadata? How does Zookeeper store this information? What I'm trying to say is, wherever in your entire architecture, the hierarchical, you can always define it in the form of hierarchy, right? For example, let us say there is a payment service. Then there is, let us say, an authentication service. Then let us say there is another profile service, right? These can have individual databases as well. These can have their own databases. What was the service? Payment service can have its own databases. So you need to have some logical separation between the databases, in the information of these databases, when you are storing it in the Zookeeper. And what is an easy way? What is one of the ways in which the Zookeeper does it? It says that, okay, fine, I'll have a root structure, and then within the root, I will have multiple directories. One directory will be, let's say, for the payment service. One directory will, let us say, be for the let's say, the authentication service, right? And then one directory is, let us say, going to be for the profile service, right? Now, within the payment service, there can be multiple other things that we can end up storing. But let's say we are trying to talk about the storage of database. We can also store some cache information. And now, let us say, in the database folder, you end up storing information about shard, let's say, one. Let's say this happens to be the one of the shards. So in the shard one, we are then going to store some files. One file will be for the master. One file be, let's say, for the slave, and another file for another slave, _2, _1, right? So eventually, these pink things are the folders, right? With which Zookeeper stores this information inside of it. And the things that I've written in black, these things are the files. What is going to be present in this master file? Let's call it master.txt. Let's hypothetically imagine it to be that way. It will actually contain the IP address for the database of shard1 for payment service. Let's see the IP address. Let's say this is the master, and let us say the IP address is 10.0.0.1. So the content of master.txt will be 10.0.0.1. Is this data structure clear to you, Prince? Is this like you were confused? Is this making some sense? That you're trying to break down your architecture into hierarchies. What is the first level of hierarchy? The services, the individual services that you have in your entire architecture. Then within a service, there can be different systems that the service is using. database, cache, other kinds of other systems, right? Within a database kind of system, the cluster that you have to manage, it can have multiple shards. So we then took a look about, let's say, shard one only. Within a shard one, you can have a file for master database, for a slave two, etc., etc. This is essentially the hierarchical data structure, the file system kind of a data structure that Zookeeper ends up following, right? Do we use Zookeeper for this purpose currently in industry? Yes, Vivek. A lot of the systems use Zookeeper for this purpose in the industry. Some systems have migrated away from Zookeeper because this is an extra system that you have to manage in production in order to run a MySQL cluster, let's say, for example, right? So because of that, a lot of people have started building things that Zookeeper does within the exact system itself. But yes, it is definitely used, highly used, right? For a lot of people in the industry use this, right? All right, guys, is this data structure that I've just explained you, this file system thing as to how Zookeeper maintains this information, is this thing clear to you? Please give me a +1 if this makes some sense to you. Like you're able to at least visualize a little bit about the data model that Zookeeper is using internally. But Zookeeper only used for DB, right? For servers, we use Envoys. So, Prince, yeah, for servers, you can use Envoys, but Zookeeper is not just used for database. It is also used for, like Kafka is also a technology that ends up using Zookeeper. Some of you may say that Kafka is migrated from Zookeeper to KRAF model, but that is not completely done. Like every company has not done that, right? It's something that is in progress. It is in transit. It is in flight. So Zookeeper is not just used by the databases. It is used by a lot of other technologies as well, right? Awesome. So guys, if this thing makes sense to you, let me also tell you. So I told you there are two things that a Zookeeper wants to store, right? Can you go ahead and type it? I'll not show it to you. Quick quiz. Can you type it? The two things that a Zookeeper needs to store. One we have already seen, which is the metadata to manage state. Metadata to manage state for system. But we have not taken config files. Yes, config. The second thing is config, which you want to store. What is this question someone has asked? There is some protocol already existing. Chick works around TCP to check health. It's very frequently and lightweight, so why not use that? Telecom industry use it for checking servers health and for remember its name. I don't remember the name of the exact protocol, Amit, but typically you can build any protocol on top of TCP. You can make it extremely lightweight by sending less headers and whatnot, which we'll see. Zookeeper does not use an HTTP protocol. It uses its own binary format, which is built on top of TCP. And yeah, you can use that. To answer your question right now, the answer is yes, but I don't remember any name, right? I mean, you don't have to remember the names of these lightweight protocols. You can use any of, you can build your own protocol as well, but I don't know the exact name of the protocol that you're mentioning over here, right? Awesome. Awesome, guys. So the second point that I wanted to mention, so this thing I've already covered, at least the metadata that we want to store in a Zookeeper cluster to manage the state for the underlying system, right? The second thing that a Zookeeper system ends up storing is the configuration. Configuration of the database that you're dealing with, right? What can be some parameters for a configuration? Can anyone tell me some things that can qualify as config parameters for a database, let us say? Number of shards. Yes, number of shards is a good parameter to be stored for configuration. Yes. IPs and ports. Amrita, configuration parameter, it's not a configuration parameter. By configuration parameter, I mean something that will definitely not change a lot. Something that is going to remain constant for a long period of time, right? For example, have you heard of that if any one of you has used AWS, GCP, or Azure, all of them end up having some sort of a key and secret with which you access a specific database? Is this thing something that makes sense to you? Right? So this is something that unless you explicitly go ahead and rotate it, unless you go ahead and explicitly update it, it remains constant for a long period of time, right? So these things that qualify as configuration parameters for a database, you can also store these things inside the Zookeeper, right? IP, I'm not calling IP address to be a configuration parameter, because the IP where you have to send, let us say, your write request for the master database, your IP address can change where you now have to, let us say, store send the writes, because if whatever slave gets promoted, because of which I'm not saying that IP is a configuration parameter, right? Something like that happens to be like something like a key or secret, it can definitely qualify to become a configuration parameter, right? Yeah, environment variables, you don't typically end up using Yeah, you can. I mean, I think it's fine if you were to even store environment variables. But typically something that you want to, let's say, use for connecting to the database, right? The configuration parameters that you will basically end up using as the configuration parameters, right? And then you don't have to over index on whether something is configuration parameter or not. But all I'm trying to say is just give you some hunch that Zookeeper ends up storing the configuration parameters as well, right? Awesome. So if this point makes sense to you guys, please give me a +1. If the fact that metadata ke saath we can also show the configuration of the underlying system in our Zookeeper cluster. Okay, awesome. Let's now focus. Yes, like Vault. Yes. So if any one of you has used a system like Vault, Vault is something that I have heavily used for at least this configuration parameters of system that I want to, let's say, connect with, right? But Zookeeper also gives you the same use case. So yeah, Vivek, you're correct. Absolutely on point, right? Awesome. So let's discuss the next concept, guys, which is called as the concept of Zookeeper nodes, right? What is the what do you think is meant by Zookeeper nodes? Can one of you go ahead and type it quickly in the chat? What do you think is meant by the term Zookeeper nodes? Can you quickly type it? Whatever you feel like is the meaning of Zookeeper node. Yes, someone is saying machines managed by Zookeeper. Machines managed by Zookeeper. Okay. Server where Zookeeper is running. Correct. Server where Zookeeper is running. Different instances of Zookeeper. Okay. So guys, let me tell you, all of you are wrong. Right? Cluster. Okay, fine. Someone has given another wrong answer. Cluster. So yeah, that answer is also wrong. Right? So Zookeeper nodes does not mean the machine where Zookeeper program is running. Okay, this is something that a lot of people get confused with in two cases. Let's say someone does not know about Zookeeper, or let's say they have a very, very, very superficial knowledge of Zookeeper, then they will get confused as to what Zookeeper nodes mean, right? Zookeeper nodes refers to the file that you are storing inside the file system. It does not refer to the node or the actual machine where Zookeeper binary is running. Okay, how does any program run, right? You take the binary of that, you'll basically download Zookeeper, you'll fork the GitHub repo, you build a binary of it, and then you'll go ahead and run it on some machine, right? The underlying machine where Zookeeper is running, that is not equal to Zookeeper node. I hope this point is clear, right? Yeah, I mean, you can call it Z node or you call it ZK node. Yeah, I mean, yeah, when you actually configure it, it is definitely called Z node. But I was just explaining it that way, which is why I mentioned something like ZK nodes, right? Is this point clear to everyone that what is the meaning of node in the context of Zookeeper? It is actually the file where your data is being stored is actually being called as node. These things where, let me go to the example. Yeah, this file where all your IP information was being stored. This is what is called as Z node, or ZK node, whatever you want to call it. Does it make sense, guys, to everyone? Can you hear me? Awesome. Where is that file? Amrita is asking. So Amrita, once you end up storing it inside the directories, that is a thing that is actually called as ZK node, right? That is where your file will be stored, right? Whatever path you have decided, right? Awesome. If Zookeeper machine shuts down, how do you retrieve all the data? Anzala is asking. So Anzala, Zookeeper ends up writing all the data in in its memory, and then it also flushes a snapshot of it onto the disk itself. So if a Zookeeper were to restart, it always has the state maintained inside of it, right? I hope that answers your question. Awesome. So with that being said, let me explain you the two types of Zookeeper nodes that exist in our system. Okay. And again, Zookeeper nodes basically mean the file. So where is the config parameters stored? Someone is asking, Shekina. So you'll get an answer to your question in exactly this, what I'm trying to discuss, right? There are two types of Zookeeper nodes, right? One is ephemeral Zookeeper nodes, and another is basically a persistent Zookeeper node. Ephemeral means something that is temporary, right? Temporary or basically volatile in nature, something that is not permanent, right? And can get deleted is basically the meaning of ephemeral in our context, right? So some information that we want to, let us say, store in a file, which may not be relevant after frequent periods of time, after frequent intervals of time, is some information that is a good candidate for an ephemeral zookeeper node. And ephemeral zookeeper node basically means the ephemeral files. So any information that may not be very relevant. For example, let us say there is a file. Let us say there is a file that is storing the information about the master database's IP. Okay, let us say there is a file that is actually storing this information. But tomorrow, but any time, any point of time, let's say there is any fault that happens, then this IP will have to be changed, right? So if an information is going to be changed very frequently, typically Zookeeper gives you the functionality of modeling this file as an ephemeral file. So what you can do, instead of just updating the data in this file, you can delete it entirely. It gets deleted. How it gets deleted, we'll take a look at that, how Zookeeper does that, right? So it gets deleted and a new file can get created, right? But when do you choose a file to be an ephemeral file? Only when the data inside of it can change very frequently. Okay. Whereas if you have some sort of a data that is going to remain exactly same for a long period of time, unless you explicitly go and you just want to get rid of that data, those things are basically stored in permanent Zookeeper nodes. For example, the configuration parameters that I mentioned, right? Because your AWS key and secret, or whatever you want to call it, Azure or GCP, does not matter. Those things will not change as frequently as the IP address of the master instance may change. Does it make sense, guys? Please give me a +1 if this reasoning about ephemeral files and permanent files makes sense to you. I hope, Shekina, you got the answer to your question. Where is the config parameters going to be stored? Amit is asking, so what the program running and checking the states will be called? Program. Okay, fine. Let me. You can call it anything, right? Zookeeper client is basically the program that is. I'll explain that. I'll get to that, Amit. Just give me some time. I'll explain, answer your question as well. Guys, is there anyone who has not understood the concept of ephemeral and permanent files? Please let me know. Okay, fine. Now let's try to see, guys, like what is exact, why does it matter, why two different kinds of file? Yeah, Shubhabrata, let me explain why do we have these two different kinds of files. Okay, fine. So I hope first of all you can you say Kafka topic name as a config parameter? Topic name, see, if you have some regex in your topic name, right? Some topics are Kafka topics, we end up defining is that it has, let's say, some, so let's say I just type my own name, and then let's say there is some sort of a pattern over here which you are getting, let us say, from the event that you're delivering, right? And then you're, let us say, having some suffix to it, let's say 1 2 3. In that case, your topic name is not constant. The number of topics can actually keep changing dynamically. So if something that can keep changing dynamically, then you cannot call it as config parameters. But if you have a Kafka topic which has a static name, let us say the topic name is, let's say, payments. In that case, yeah, you can definitely go ahead and call it as a config parameter. Awesome. All right, guys. So now let's try to take a look at how this ephemeral node basically works and why do we even need that. Okay. So let's try to discuss the concept of sessions first of all in Zookeeper. Okay. So what is the information that these files are maintaining? Let me try to explain it with an example. Okay. Let's take these 3 different shards. Okay. And then within these shards, all of them end up having some sort of some slaves. Okay, same. Now let me try to model it in the form of a Zookeeper file structure, the way it will be stored. So let us say all of this is happening for, let's say, a different service. Let's call it a profile service. Okay, let's say the profile service has shard 1, shard 2, shard 3, and these are the slaves, right? These are basically the master nodes, master databases. Okay, how will the Zookeeper store this kind of an information? Okay, what will it store? What will it say? It will basically say, okay, fine, let me store the profile service, right? Inside the profile service, it is then going to have, let's say, a folder for database. Within a database folder, it is, let's say, then going to have some config parameters, right? Within a config parameter, it can have a permanent node where it can store, let's say, something like a key, something like a secret, right? What are these? These are permanent Z nodes. Basically, these are permanent files where the actual key and the actual secret is stored, right? Then, and you can also have like count number of shards or whatever information you want to have, right? Now, let us say there is also, apart from config, let us say there happens to be a information for a specific shard, right? Let's call it shard 1. So let's say there's information for shard 1. What information will we have over here? I hope everyone can understand that we'll have, let's say, a file for master IP. We'll have, let's say, a file for master, let's say, port, right? Let's say there is a file for the slave 1 IP. Let's say slave 1 port. And you can obviously go ahead and club these two informations in the same file as well, right? I'm just explaining it explicitly, because of which I'm trying to break it down into in this fashion, right? Let's call it slave 2 IP and slave 3 IP, right? Now I want you guys to pay extreme focus on this, because I'm going to be covering two concepts over here. One is the concept of sessions and heartbeats, both, right? And plus ephemeral nodes. Okay, so someone asked why these files are supposed to be ephemeral in nature, right? The number one reason for these files to be ephemeral in nature is the first responsibility of Zookeeper, which is you need a system which can manage the metadata about the underlying cluster. One of the metadata that you have to manage for the underlying cluster is its health. You need to, at all points of time, figure out whether something is healthy or not. And the set pattern in which Zookeeper typically ends up doing it is whether, if let us say in your cluster, the master database is, let's say, alive. In that case, the master database is going to emit a heartbeat, and it is going to ensure that the data that is stored in this master IP remains stored over there, right? So what the master database is going to do, there is going to be a Zookeeper client, that is a program that is going to be running in near this master database near yourself, and it is going to emit some heartbeats. It is going to emit some heartbeats. These heartbeats are going to eventually reach the Zookeeper manager, and once a Zookeeper manager gets these heartbeats, it is going to retain this master IP file. Why? Because it knows that the ownership for this master IP file is managed via a session that was created when this entire Zookeeper system was started. And how was the session created? It was created by this master database. So what all happened? Step 1, Zookeeper system started. Zookeeper system started. Step 2, a session was created by the master database. And internally, how did the master database create this? With the help of a Zookeeper client program, right? As soon as this session was created, the Zookeeper manager knew that the information stored in master underscore IP file is for the master database. Master database is session rather. So if at any point of time there is no heartbeat that the Zookeeper manager is able to get from a specific session, it will go ahead and delete this file altogether, right? Let me repeat this entire process. Your Zookeeper system starts, right? Once your Zookeeper system starts, all the Zookeeper clients, which are programs that are running along with your master database, they create a connection with the Zookeeper system. Where do they send the connection? There is a Zookeeper manager, which is a program that is running inside of Zookeeper, which says, okay, fine, this master database wants to connect with me. All right, let me go ahead and create a file if it does not exist, a master IP file, or if it already exists, let me just make sure that I'm not deleting this file, this master IP file, right? And how do I know that? Because a session is active between the master database and the Zookeeper system, right? And now, if the master database is now what the master database is going to do, it is going to send this heartbeats. It is going to send these heartbeats over this session to the Zookeeper manager. As long as the heartbeats are reaching the Zookeeper manager, the master IP file will be kept as it is. As soon as these heartbeats stop getting sent from the master database all the way to your Zookeeper manager, the Zookeeper manager will delete this file. As soon as this file is deleted, anyone who wanted to perform a write to the system will see that, hey, there is no master now over here. And then a leader election process can start. Are you guys able to understand this entire thing that I've just mentioned over here? I know it is very complex, but if there is anyone who has not understood any bit of it, please type no in the chat. I will explain it again. Zookeeper client would send the heartbeat. Yes, Sudhir, the Zookeeper client would send the heartbeat. Pranav is asking, so it's the master responsibility to tell Zookeeper that it is alive? Correct, Pranav. It is the master's responsibility, and master database does not know, hey, I have to send it over here. You have to run a Zookeeper client program along with the master on the same machine, and that client will basically send all of these heartbeats all the way to your Zookeeper manager. Okay, so someone has mentioned they've not understood, right? Kunal, I will explain it again, Kunal, don't worry. Let me just quickly answer the questions. Who was saying lead election starts when right request hit, or it will start automatically. So Animesh, okay, leader election, how it will happen, I will explain that. Just give me a moment. But so far what I've said, Shri is asking, so everything created by a specific session will be deleted if that session is gone. Yes, Shri, the files that were created by that session, if those files are ephemeral, the files that were created by that session, and if those files are ephemeral, they'll be deleted. If, however, a session was started and a permanent zk node file was created, in that case you won't be deleting that file. I hope this point is clear. Who asked this question? Shri, I hope this point is clear to you, Shri. Is session will be maintained throughout? So yes, Vivek, you have to maintain the session throughout the lifetime of the product, and that is why it has to be an extremely lightweight protocol over TCP, and hence Zookeeper uses its own binary format on top of TCP to make it extremely light. HTTP is a very heavy protocol. You have to send so many headers, so many cookies and whatnot. It just creeps into it, right? It makes the payload very heavy, and if you create that connection for a long time, it is not possible. So instead of that, Zookeeper uses its own binary format on top of TCP to create an alive connection, right? Awesome. I hope that answers your question, Vivek. So we are configuring Zookeeper client with the master's machine only. Zookeeper client with the master's machine only. No, Himanshu. Okay, fine. I'll answer this question. No, that is not correct, Himanshu. I'll explain that. What if only DB process in that DB machine dies and not the machine itself? Will the Zookeeper still send the heartbeat? Yeah. If the process Zookeeper client is basically looking for the healthiness of this, the database process itself. If the database process has stopped, it can no longer take reads. It can no longer take writes. So Zookeeper client will send it. I hope that answers your question, Nitin. And for anyone who did not understand that, let me explain it to you once again. Okay. What is the first step? First of all, the Zookeeper system will get started. I think it was Kunal who had not understood this question, right? So Kunal, can I unmute you? Kunal, do you have an active mic? I can unmute you and explain it to you, and it will probably answer a lot of doubts for other people as well. Can I unmute you? Okay. No. All right, fine. If you don't have a mic, fine. I'll explain it to you once again. So let us say the Zookeeper system gets started. That is the first step. Okay. As soon as okay, don't have a mic. No issues. So as soon as the Zookeeper system gets started, what do I mean by Zookeeper system? So there is this Zookeeper system, and inside of the Zookeeper system, there is a Zookeeper manager which is sitting there. Okay, let me give you an analogy first of all, right? Let us say that there is a manager for a club that is, let us say that you want to visit in your society. Let us say there is a club, and inside the club, there whoever is entering over there and whoever is, let us say, going to the gym, which the a facility that is available in your club, there is some register that is being maintained over there, and in that register, the manager is basically maintaining some information as to who all people have actually come here, who all people are actually working over here, which all people have actually left, right? This is the responsibility of a manager, typically, who is sitting in front of a club, who is maintaining a register, and in the register, you're maintaining information for everyone who wants to, let's say, use a gym, right? Similar to that, there is a concept of a Zookeeper manager as well, right? What is the responsibility of Zookeeper manager? The Zookeeper manager needs to manage the state of these files. Okay, how does it treat the state of these files? First of all, as soon as a database system, let us say this MySQL database has a master, and it has, let us say, two slaves, slave 1 and let us say slave 2. Along with the master, you will also run one more code, which is going to be called a Zookeeper client. A lot of people will explaining or talking about this, they'll just say that, hey, master is going to send heartbeats all the way to the Zookeeper system. No. How will the master database send it? There is a program that is running on the same machine which has the master database server, and the Zookeeper client will create a session. It will create a session, and that session will be captured by the Zookeeper manager inside the Zookeeper system. Okay. And after this, the Zookeeper system will see, okay, fine, a Zookeeper client has sent me some requests, and in the session it tells that, hey, I am the master database, and this is my IP address. This information is sent in the first request of this session by this Zookeeper client. As soon as this information lands on the Zookeeper manager, the Zookeeper manager goes ahead and figures out the exact directory structure, and it then creates a file over there. What is the name of the file? The name of the file happens to be, let us say, master_IP. The name is not set in stone. You can call it anything. You can call it ABCD also. It's just that the file is created by the Zookeeper manager. What will be the timing of this session for how long. So Kunal, first of all, have you understood that this session needs to be initiated when you want to first of all create this file? First of all, is this point clear? I will answer your question in my second sentence, but please give me +1 if this thing makes sense. How is this file created for the first time inside the Zookeeper file system? Is this point clear to you? Awesome, +1. Thank you very much. To answer your second question, which is what will be the timing of the session and for how long, this session needs to be long lived. It needs to be long lived. Long lived does not mean infinite period of time it will just exist over there, right? It will stay there for hours. But if let's say if it gets broken, then a new session will immediately be created again. But the reasoning is, but the important question is, why does it need to be living for hours? Can one of you answer it? Why do we need this session to exist between the Zookeeper client and the Zookeeper manager? Why do we need this connection to be persistent? Why do we need it to be long lived? Can anyone think about the reasoning behind it? Why do we want to send this? Exactly, for the heartbeat. Exactly. So Kunal, does this answer your question? This session is what is also, first of all, it was responsible for creation of the file. Now it is responsible for the heartbeats. I'm drawing hearts. My drawing is very bad. I hope the explanation, Kunal, is clear to you, that how this ephemeral file gets created. Is it clear to you? I have to explain why it gets deleted also. Awesome. Thank you. Now let's see why it gets deleted. It may just get deleted also, right? Why? Because it is an ephemeral file, and I mentioned that an ephemeral file is not going to be stored over there all the way for the entirety of the application. So it will get deleted. When will it get deleted? This is a question you should ask. Can one of you answer it in the chat? When will it get deleted? Yes, Pranav. Yes, when the master goes down. So when the master, don't call it master, call it in this way, that when the Zookeeper client that is running along with your master is not able to send these heartbeats, in that case, the Zookeeper manager will see, oh, there's no request that is coming from that should have actually landed because after this amount of threshold, and hence the Zookeeper manager will delete this master IP file. Is this thing clear to everyone, that how the master IP file will get deleted if your the master database के साथ वाला Zookeeper client is no longer able to send the heartbeat? Is this point clear to everyone in the class? Please give me a +1, guys. Thakur, we know that last written slave becomes the next master, but how to select this, and does Zookeeper client will recreate the new config after some time? Yeah, Thakur, just wait. We'll take a look at the master leader election again in just this next step only. But I just want to ensure that so far what we have discussed is clear to everyone. Is there anyone who has any doubt on what we have discussed so far? But why we need long live connection? Every few seconds, client can send heartbeat to master to tell he's alive. So Prince, typically creating these TCP connections, I explained this in the last class, doubt session part of things. The TCP connection that needs to be created for sending a heartbeat, it's a 3-way handshake process. And if you have to create this for after every few seconds, it takes some time, and it is heavy computation as well. And your Zookeeper client, I mean, the database server is not just responsible for creating of these TCP connections after every few seconds. So instead of you doing this 3-way handshake about a TCP connection to create that from scratch every time, you instead of that already use a long running connection. Does that answer your question, Prince? Please give me a +1 if it makes sense. And if it does not, please post a question in the questions tab. I will explain it in depth how this 3-way handshake is performed, right? Awesome. Is there anyone who has not understood, has any doubt? Please mention it. Otherwise, we will understand how master election works. Master slave election works with Zookeeper. I have to explain the concept of Zookeeper watch for that. But is this point clear to everyone? I hope there is no doubt on whatever I have discussed so far. Make sense to everyone? Awesome. Let me drink water. Just give me one moment. Okay. Just a second. Break? No, not right now. Let's complete this thing, guys. Let's complete this master slave election. Immediately after that, we'll take a break. It just take 10-15 minutes. Just 10-15 minutes. Okay. I hope you guys can bear 10-15 minutes more of me speaking and yelling. Awesome. So now let's take a look at master slave election as to how it works in Zookeeper. So far we have discussed just a question. There will be one manager for each Zookeeper client. Shri is asking. So Shri, there will be one Zookeeper manager in every Zookeeper machine. Okay, it can serve requests from multiple Zookeeper clients. Need not be that way. Okay, awesome. Yes, Himanshu, you're correct in your first half of the sentence, but not in the second half of the sentence. Typically, when you're initiating the connection, the database itself tells it, hey, I'm the master. The first one typically will not be elected as the master because I'll tell you later on. Like, what is the reason for it? Please put it in the questions tab. I'll tell you the reason behind that as well. Okay, fine, awesome. So now let's try to see how the master, how a slave can get promoted to become a new master. This is the problem statement that we want to now discuss. Master slave election is exactly this. When the main master stopped taking the rights, how can you promote a slave to become the new master? This is exactly what we want to discuss, right? I hope this problem statement is clear to everyone. Please give me a quick +1, guys. This problem statement, this is exactly the question we want to answer. How does a slave get promoted to become a new master, right? Awesome. So first of all, before understanding how a slave gets promoted to become a master, let's take a quick look at the concept of Zookeeper watches. Right? The concept of Zookeeper watches is as below. Let us say, okay, fine. Let's say again the same. Let's say there is a master and then there are a few slaves. And let us say there is a file structure for it. Let's say payment service. Inside of payment service, you have, let's say, something like a database. Inside of database, you end up having, let's say, some shard 1. And in shard 1, you end up storing information for, let's say, the master IP. Let's say master IP and port both are stored in one only. Okay, fine. Then let us say there is a slave 1 IP and slave underscore 2 IP. Okay, now can you guys tell me, based on our previous discussions, let's say this is slave 1, let's say this is slave 2, and let us say this is the master. Can you tell me how would the slave know? How would the slave know who is the master? How would the slave know who is the master? Because the slave needs to pull data from the wall of the master database, right? So how will the slave know what is the IP address of the master? Can you answer it in the chat? How will the slaves know how to connect with the master database? Kapil, you're saying configuration. No configuration. See, Kapil, if you store it as a configuration over here, then you need to update it also, right? Right now the master is over here. What if the master becomes over here? How will this slave know ki bhai, initially I stored in my configuration parameter that this is the master, but now master needs to be over here. So yes, Zookeeper, right? It will send a request to the Zookeeper machine. Basically, the Zookeeper manager will get this request, right? And the slave is not sending. Guys, anytime when I say the slave is sending the request, can you guys appreciate the fact that there is a Zookeeper client that is running on the same machine as a slave, which is sending the request to the Zookeeper manager? I don't want to say that again and again and complicate the diagram. Everyone clear with this? That when I say master is sending a request to Zookeeper or slave is sending a request to Zookeeper, it's a Zookeeper client program which is actually sending this request. Okay, awesome. So now let us say the slave is going to send a request to the Zookeeper system machine basically, and from the machine it is going to specifically send a request for this master IP file. It is going to specifically send a request for this master IP file because it knows that master IP file is the one that is actually going to contain the IP address of the latest master, and whatever is the value in the master IP file, that will be returned to it by the Zookeeper machine, and it will then connect with it. Correct? Now let's say, yes, Zookeeper client also running at slave. Yes, Rishabh. Yes, this is exactly what I said, right? When I say slave is sending the request, I mean that Zookeeper client is sending that request. Okay, awesome. Now what happens? Let's say the master IP file immediately for some time got deleted. Let us say, okay, in that case, your slave, can you understand that your slave should understand that, hey, this file has been deleted, or let's say a new value has been written into this file, and I need to update my read request. Instead of this master, let us say I now need to send the request to this master. What if initially, let's say this master IP file had a content of 10.0.0.0, and the IP address of this master is also 10.0.0.0, and the IP address of this slave is, let us say, 10.0.0.1, right? Let us see the election, this leader election process happened, and this slave actually became the new master. Let's say that happened. We'll see how that happens. But let us say the slave 2 became the master, and this IP address was actually changed to 10.0.0.1. How will the slave 1 get to know that now the master has changed? Instead of here, I need to send my request to here, right? How will the slave 1 know that the request where I have to send my write request is not this IP, it's this IP of this machine? How will the slave 1 know? One way is that the slave 1 can repetitively keep polling. Repetitively, for every request, the Zookeeper client in the slave 1 database will call Zookeeper manager and ask for the IP stored in the master IP file. Is this thing clear? That before performing any write, the slave 1, the Zookeeper client running for slave 1 database can send a request to the Zookeeper manager. Zookeeper manager will send the IP address written in the master IP, right? Correct. What if there was a let's reverse this problem. Let's say that the slave was actually requesting for this IP every time. Why was it requesting? Because the IP may have changed. Let's change the game a little bit. Let's make the architecture in such a way that whenever this IP address changes, the Zookeeper manager broadcasts this request to all the Zookeeper clients. Does this point make sense to you guys? That instead of polling repetitively, what if the Zookeeper manager pushes any change for the master IP file, to all clients who are interested in it? Does this line make sense to you? That there is one way in which you can send before sending any write query, you say, okay, fine, I'm going to go to Zookeeper, get me the latest IP address from the master IP file, and then going to send the request. This is one way. But you do this repetitively. Why are you doing it repetitively? Because the redirection would have happened and the IP address would have changed. But now, what if the Zookeeper manager, which is having this access to this file, what if it knows that, hey, as soon as this file changed, let me send a request to all the interested Zookeeper clients. We'll take a look at what it means by interested Zookeeper clients. But let's say, what if it pushes this value? In that case, the Zookeeper client for the slave will not have to make repetitive requests all the way to the Zookeeper manager just for getting the access to the IP address of the master database. Is this point clear? That instead of you making, let's say, thousands of poll requests, what if the push from the Zookeeper manager only happens one time, when the master IP actually changed? Is this point clear to you? That the push architecture, where the Zookeeper manager can actually push the change to all the interested Zookeeper clients, is a much better way to reduce the latency for the slave to actually get replicated, to get the replications from the master database. Does this point make sense to you? Please give me a +1, guys, if this point makes sense to you. I'm not getting a lot of +1. Is this? If it is not clear, type a no. I will explain it again. This is typically, someone has mentioned animation observer. So in LLD, you study this observer, what do you call it? Design pattern, right? This is exactly what it is. PubSub also you can call it. But observer pattern, whatever you want to call it, English, whatever English you want to use. Essentially, you are watching for some changes to a specific Zookeeper node. This is basically okay, Pranav, don't worry if it is taught only in backend track, does not matter, right? Observer pattern is just the fact that if something changes at a certain place, it gets pushed to you, right? You are just a receiver of all of those things, right? Just forget all of the design pattern thing that I mentioned, right? But essentially, the simple concept that I wanted to explain was the Zookeeper watch concept, right? This is exactly the concept. So what happens how is a watch established? if there is a Zookeeper client which, let us say, is interested in a specific file. Let us say that file is in some location. Let's call it, the file name is, let's say, file. Okay, let's say the name of the file is file. If the Zookeeper client is interested to know if any change happens on this specific file, it should get a notification. The Zookeeper client is going to register a watch. The Zookeeper client is going to register a watch on the Z node, ZK node, whatever you call it, F file, which has the name file. So any change, if this file gets created, the Zookeeper manager will send a notification to the Zookeeper client via the same session. If, let us say, it gets deleted, it will again send the same. It will again send the same location. If it gets, let's say, updated, in that case as well, the Zookeeper manager will send a notification to the Zookeeper client on the same session. Is this point clear to you guys? That you register a watch on the Zookeeper node file, and okay, it is not clear to someone. Let me explain it once again. Okay, so what happens? Zookeeper client, let's say this is Zookeeper client, which is running along with the slave database. Okay, let's say this is the slave database, and it needs to get access of the IP address of the master database. Let us say this is what it is interested to get to know about, right? So what will it do? It will basically say, I'm going to go to the Zookeeper system. And ask for the IP address from the master IP file. Okay. Now you could have done this repetitively again and again, right? Just before the slave is actually going to read from the master database, right? It is just before the slave database is actually going to read from the master database. It is going to send a request to the Zookeeper cluster saying, get me the master IP for this MySQL cluster, right? From the specific file. Let's call that file as FILE, right? What if for every request it has to maintain this? It will be a lot of latency. It will have to perform this request before every read from the master database, right? Now, what can the slave do? Instead of doing this, what Zookeeper gives you as a functionality, the Zookeeper can say, hey, if there is any change that happens on this file, just let me know. I will not keep asking again and again, right? For example, let's say there's a class change schedule for our lectures, right? All you can say is that Scalar support should send you a mail. You don't send a mail after every 1 hour. Hey, is there a change in the lecture schedule for this batch? Is there a change in lecture schedule for this batch, right? That is a very unoptimal way of doing it. You can do that. It's very unoptimal way. What is the optimal way? That they push this change to you via an email or a WhatsApp message. This is exactly what is happening over here as well. If the master IP file gets changed, deleted, something, if you have set up a watch, what do I mean by you? The Zookeeper client. If the Zookeeper client has set up a watch on a specific file, which happens to be a Zookeeper node, in that case, an event, kind of like an event trigger, the change event will be sent back to the Zookeeper client. Is this point now clear to everyone? What is the concept of Zookeeper watch? Is this point clear to you, everyone? Anyone who has not understood this? I hope it is clear to everyone. Please give me a +1, guys, if this thing makes sense to you. The concept of Zookeeper watch. I hope this is clear. If this is clear, then we can quickly just, in 5 minutes understand how master election works using Zookeeper, and then we'll take a 5 minutes break or maybe 6 minutes break. Anyone who has not understood the concept of Zookeeper watch, I will explain it again, guys. Anyone who not explain. If there's anyone who has still not understood it, add a question in the questions tab. I will explain it again in the doubt session. Right? Yeah, we'll get 10 minutes break. Fine. So if all of you have understood at least the concept of Zookeeper watch and you've understood the concept of heartbeat, quickly let's take a look at the master election. Basically, how can a slave be promoted to become a master? Right? Awesome. So let me draw a diagram. Let's say this is, I'll draw it towards the left. So let's say this is the master. And let's say this is the, wait just a second, guys. This screen is getting very dirty. Let me wipe it a little bit. Oh, sweat. Awesome. So let's say this is a slave. Let's call it slave sample pencil slave 1. And let us say we have a slave 2. Okay, now let us say this. Okay, I'll draw it again. uh, this is, let us say, the zookeeper, right? And how is the zookeeper structure going to look like? Whatever way you have defined, let us say, let's call it, let's say, the slash something like a payment service, and then within the payment is this Apple Pencil. Okay, inside of, guys, let's take a break. Let's take a 5 minute break. My Apple Pencil is not working. I'll just recharge it once. There's some issue with it. Let's take a quick break, guys. Yeah, fine. So it's 10:41. Let's come back at 10:50 sharp, please, guys. At 10:50 p.m. sharp, we should come back, right? Okay, fine. Please be back by 10:50, guys. I'll not waste even a single minute, and will immediately get started at 10:50, guys. Okay, awesome. चलिए ठीक है, ब्रेक लेते हैं. Hey guys, are you back from the break? Can you hear me? Hello. Okay. Um, please give me a +1 if you're back from the break. If I get enough +1s, we can get started. Awesome. Fine. So we were taking a look basically at how master election happens in case the master basically dies, right? So which of these slaves will actually get promoted, how it gets promoted to become a master is what we want to take a look at, right? Let me get started at exact 10:50 because some people may be waiting for the clock. Yeah, it's 10:50. Fine, let's get started. So we're trying to see over here how one of these slave databases can be promoted to become a master, right? Now, how will the sequence of events basically happen? The first thing that will happen will be the master database, let us say it dies. Okay, so if it dies, the master database, I hope you can imagine that there will be some file in some after some a few directories, and it will have, let us say, the information about the master IP, let us say .txt, let's call it a text file. Okay, this file will get deleted once the master database is no longer alive, because it will not be able to send heartbeats. These heartbeats will no longer be being sent by the Zookeeper client that is running on the master along with the master database. Those things will not be sent to the Zookeeper manager, which is running in the Zookeeper machine, and hence it will delete this file. Give me a +1 if this thing makes sense to you. That the file will get deleted. That is the first step that will happen when the master machine will stop sending the heartbeats. Right now, all the people who have created a watch on the Zookeeper node, on the Z node, on this basically file, all the people, by people I mean all the Zookeeper clients, all the Zookeeper clients that have created a watch, a Zookeeper, a Zookeeper watch. Yeah, let's just call it watch. All the people who have created a watch, the slave 2 and the slave 1, they have created a watch. They will see that, hey, this file is deleted. They will get a notification back from what entity? They'll get it back from the Zookeeper manager. The Zookeeper manager, which is running inside of the Zookeeper itself, it will say, hey, this file is deleted. Now do whatever you want. Zookeeper manager won't say ki jao election karo. It won't say that. It will say the file has been deleted, over which you had actually set up a watch. Is this point clear to you? This step 2, that since they have set up a watch, a notification will be sent that this file has been deleted. Please give me a +1 if this thing makes sense to you. Himanshu is asking, what is a watch? A session. Session is long running. Watch is just so you're basically saying that any change that happens on this file, you are asking the Zookeeper manager to notify you of that change, right? And it is short lived. As soon as you get that change, you have to re-establish that watch. The slaves will have to re-establish the watch all the way with the Zookeeper. They have not permanently subscribed for the change. Permanently, it is only the heartbeat that is being sent, and heartbeat will basically be sent by the slaves as well, right? What if the slave file needs to be deleted? It is possible that slave underscore 1.txt may be deleted, right? Because the slave is no longer alive. Session is the only thing that is constantly created, a long running connection. But this the watch, it is not a long running connection. Once you get the response for any change that happened over there, the watch will be broken, and the slave has to now create a new watch. Again, it will create a watch on the same entity. Okay, I hope that answers the question, Himanshu. Okay, the second thing, someone, okay, you've just mentioned subscribe on changes, right? Awesome. So I hope you've understood that a delete event will be sent by the Zookeeper manager to the Zookeeper client, which is running on, let's say, slave 1 and slave 2, right? Now the Zookeeper client that is running on the slave 1 and slave 2, it will see, hey, the master file has been deleted, and now the Zookeeper client will tell the database process that is running over here on the slave machine as well, that no master is now existing for our cluster. Let's conduct a leader election algorithm. Is this point clear to you? As soon as the Zookeeper client gets an event that master file has been deleted, the Zookeeper client tells the database process. How is it telling? So there is going to be a database process, DB process, and a Zookeeper client running on the same virtual machine or server, whatever you want to call it. And the Zookeeper client, it will see, hey, a delete event has been received about the master IP file. Now I need to tell the database process, please begin the leader election process. Please begin the leader election process. And now, is this point first of all clear? Is this point first of all clear to everyone? That as soon as you get the delete event, the Zookeeper client will get this. Zookeeper client will tell the database process, which is also running in the same VM, the same server, that please start with a leader election process. And now, whatever algorithm you want to use for leader election, what the one algorithm that we ended up discussing, that these slaves, this is slave 1, similarly slave 2, these people will communicate amongst each other using gossip protocol, and they will figure out which of these slaves actually has the latest latest database right in their wall files. Let us say that slave 1 has the latest updates. If slave 1 happens to be the latest update, then slave 1 will send a request by creating a session to the Zookeeper manager. Hey, I am the new master. Okay. It is very probable that what if both of them had the exact same wall rights? Both of them would have sent the same right, but the Zookeeper manager will accept the first request that actually lands onto the system, and the Zookeeper manager will then create a master IP file, because the slave is actually saying, hey, create me a master, create me as a master in this session, the request that it is sending, and it will then create this master IP file, and in the master IP file it will store the IP address of slave 1, which is our new address. And now the slave 2, since it had set up a watch on the master IP file, it will get a notification that, hey, this file is created, and now your new master is slave 1. This is how slaves in your cluster can get access to the new IP address of the new master anytime a leader election algorithm happens, by reading the file from the Zookeeper cluster. Does this make sense to everyone? That first, the master machine won't be able to send any heartbeat to the Zookeeper node. First point. The second point is that as soon as the heartbeat is not being sent, that file will be deleted from the Zookeeper machine. Who will delete this file? The Zookeeper manager will delete this file. As soon as the file gets deleted, anyone who had set up a watch will get a notification that delete has happened. Correct? Anyone who has set up a watch, they'll see that, hey, a delete has happened. As soon as they see a delete has happened, they will get this response by the watch that they had set up. Then the Zookeeper client will tell the database process, let's conduct the leader election process. Whichever slave wins in this leader election process, it will send a write request. It will say, hey, let's create this master IP file. Right? As soon as that file is created, the new master IP file will be created, and then all the other slaves in my cluster who had set up a watch, they will again get a response saying that, hey, this file is created and a new IP address has been created. Make this your new leader. Please give me a +1, guys, if this thing makes sense to you. This is simply how the Zookeeper assists in the leader election process. Please give me a +1. I can't see. Is this not clear to you guys? Okay, wait. So now saying slave once becomes the master, creates a new session with the Zookeeper manager. Slave once becomes the master. Yeah, yes, Shekina. Yes, it will create a new session, because the session. No, wait. What if it already has an existing session? No, it won't create a new session, Shekina. It won't create a new session. It's just that the file that is going to be managed with this session, that will change. The only difference is, once a slave is promoted to become a master, the file that is associated with that session, only that will change. Okay. What was the gossip between the two slaves, Amit? Basically, these two slaves need to figure out which of these two slaves has the latest rights in their wall file. Whichever has the latest right, how do they figure it out? They'll gossip amongst them, that whatever protocol, they'll use some protocol, right? Gossip protocol happens to be one of them. They'll basically talk amongst them and they'll figure out, hey, I have the latest rights. The other one will say, okay, fine. Once they've agreed that one of the slaves has, whichever slave has the latest rights, then that will send the request that, hey, elect me as the master. Right? Why don't change the IP in the file only? So because, yeah, you can go ahead and change the IP in the file only, but typically the way Zookeeper works, it tries to create immutable files, and which is why it calls all these files as ephemeral nodes, right? Which is why you just delete the file altogether instead of just changing it, right? So manager don't need to decide, they themselves will decide. Yes, Amit. Zookeeper manager does not do the leader election. The same Zookeeper cluster will also solve the same problem for a Cassandra cluster also. The redirection over there can be completely different. Zookeeper's responsibility is to only tell you if you have set up a watch, hey, something has changed. That is the only responsibility of Zookeeper manager, and to also keep a track of the heartbeats that are being sent. That is the only thing that Zookeeper has to do. So okay, what are the other questions? So when the file is deleted, don't we need to create new watch when it is recreated? Yes, Shri, a new watch will be created. A new watch is always created, but let me just write it down first of all. A watch is temporary. For example, let us say this was the watch. Let's say this was the connection. Okay, let's say this was the connection for the watch. This is, let us say, over here file 1. It has some content 10.0.0.1, and let us say this is Zookeeper client 1. Okay, now as soon as you get some event from here, let's say deleted, then this watch will be destroyed, and the Zookeeper client will again have to create the watch with the same file. I hope that answers your question, Shri. So a watch is associated with a file location, not with the file itself, since the file is deleted. Yes, you don't say file location. You say that, hey, I want to search for master IP. Yeah, I mean, in some ways it is like a file location, but in the payload for your request, you specify, hey, I am interested in master IP file. Set up a watch for this file. Hope that answers your question, Shakina. Okay. How did all of these happen before Zookeeper was developed? So Zookeeper has been there for a very long period of time, and if when Zookeeper was not there, people used to do the same solution. They used to build it manually. This is exactly what you have to do. There's nothing fancy that is happening over here, right? You would have built the system yourself. It just might not have gotten as famous as Zookeeper, right? Then someone built it as a Zookeeper project. They open sourced it with Apache license, and it became famous, right? Same logic would have been followed before Zookeeper as well. Will master file be deleted only when the master go down? So the file will be deleted if, let's say, there is no heartbeat that is being received by the Zookeeper node, and since it is ephemeral, it will get deleted. Actually, said when new master IP is created, slave 2 gets notified. So got confused. Oh no, so when the new master IP file is created, slave 2, yes, this is exactly what I said, right, Sri? So when the new master IP file is created, the slave 2 will get notified, because slave 2 will have to again. So once slave 2 would have received the delete event, the master IP file is now gone, then the slave 2 would have again created a watch, and then when the new file was created, the slave 2 would have received a event that, hey, the file has been created. So it's a 3-step process. How does, okay, Zookeeper is the governor. Yeah, okay, fine. How does all the clients know when to create a new watch? So Shekina, once you had created a watch, and once you get the response, now it is your responsibility to again create a watch. As soon as you get the response from that watch, right, you have to now, it is now your responsibility to create that watch again. I hope that answers the question, Shekina. Watch is something like an event? No, Vivek. Watch is like a connection. Watch is like a connection. It's like a connection where you're saying, I'm interested in anything that happens to this file 1.txt. If you update it, create it, delete it, send me some event. And as soon as the Zookeeper client gets its event, it will have to create another watch again, because this watch gets destroyed. Okay, even if file is not there, we can create a watch. Yes. Even if the file is not there, you can create a watch. As soon as that file gets created, Zookeeper will send you a request. Will send you an event. Right? Awesome, guys. So with this, it marks the closure of our discussion with respect to Zookeeper, at least, right? I will share not the documentation, but quick post lecture notes. You can take a look at the post lecture notes yourself. You can read through it, and even on internet you can explore a little bit more about it. But this is essentially what I wanted to discuss with respect to Zookeeper. So Shubhabrata, I'll take your questions after the class. I mean, if it is not a very pressing question, else you can add it in the questions tab. I want to now begin some discussions on asynchronous tasks and Kafka. I want to start out with it. Is it a burning question, Shubhabrata, or can we discuss it in the doubt session? If it is extremely burning, then we can discuss it right away. Hey, let me know. Okay, fine. Yeah, then please raise your hand and unmute you. Yeah, go ahead.
Hello, hey Nikhil. So I have few questions. What I understand is, Zookeeper is helping us to um, copying the data in master slave architecture. Is
Sorry,
that
is helping us what do what?
replicating data in master slave architecture? Is that a
Not
correct?
just replicating, not just replicating, but also it is helping in the service discovery problem, right? For example, if the application server, if one of the application server wants
Yeah, I
to,
meant that only. I mean, it
okay,
is. Yeah. So
yeah,
what about multi-master? I mean, is it that can Zookeeper can be used for multi-master as well?
yes, heartbeats. So what if in the multi-master setup, one of the master just goes away? It is not available. Would you be replicating the request that landed on another master to that? How will
So
the other master even know whether to send a request to this?
So in that case, also we have to just keep the how it will be understand that this is my master and all. So there is no master concept over
Yeah.
there.
So then there is no master over there. So you'll just create some. You'll have the same files. You'll just say master one dot txt, master two dot txt, master three dot txt, and anytime you want to, let us say, one of the master wants to send the write to all of them, it will basically look into the folder master dbs, and whatever are the files inside of it, it will see that these are the active nodes to write to. It will send the write request to that.
So there can be multiple right? I mean, we know that the tunable consistency is there, right, in
Yeah,
multi-master.
yeah, yeah,
So
yeah, yeah.
so if multiple node can copy multiple. I mean, what I meant is multiple node can copy from multiple nodes, right?
Yeah, 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 yeah.
So how we can configure that over here?
So you have to just specify it in this in the master in your Zookeeper, whatever this master folder is, right? Master database folder. You just write the IP addresses of all the active master IPs over here. Then you set up a session which with each of the database, the clients that are running on each of the database. If they're alive, then these files will have the IP address over it. And then the gossip protocol that happens between these master databases, it will at any point of time when it wants to read from a specific file, it will go to this master folder and it will see whether the file actually exists over there. It will read the IP address and then it will fetch the data from that place, or it will either write to it amongst the masters itself. I mean, what you have to just think is how will you model this file system, and then you will use the exact same concept of heartbeats and the concept of watches.
Okay, so can this be used as a user interaction as well before the hitting the database? So basically, Zookeeper is helping us find the IP address. Is it correct understanding?
Service discovery, yes. Service discovery,
Yeah.
yes.
So when a request coming from user,
Yes.
before hitting database,
Yeah.
we are checking what is the master IP, right? Which
So
master database it will go to.
no. Application server, let's say this is the application server, it sends the write to the database proxy, whatever, right? So database proxy needs to know what all are the IP addresses to which I can actually send this request to, right? So database proxy is going to be, in that case, going to be talking with the Zookeeper cluster.
Okay, got it.
Does it make
Okay.
sense?
Yes, yes. So
Okay.
there is a database proxy and data Zookeeper
Yeah,
will
yeah,
be. Okay, got it. Okay, so in this case, whenever we are actually getting a write or read request, we'll be anyway call Zookeeper to know what is the IP address, right?
but not always. Not always. If you, that is the whole concept of watch. You want to get that IP address if, let's say, that file has changed, or if that, let's say, that file has been deleted. So that is why the concept of watch is important. That change will be pushed to you. Otherwise, for every write, you'll have to make a request to this Zookeeper cluster, and
So
hey,
in
you'll have to
this,
say what is the IP address. Yeah.
so in this case, Zookeeper proxy also need to keep in watch, right?
Zookeeper proxy. What do you mean by
Sorry,
Zookeeper?
not I mean the database proxy needs
Yeah,
to
yeah.
keep.
See, no. So no, you're getting confused. All I said is the client, Zookeeper client, maintains the watch. You can
Yeah.
run the Zookeeper client anywhere in the database proxy, in the database server, with the cache, anywhere you can run it,
Okay, okay.
right?
And okay, so if there is any change, then only we'll be calling Zookeeper, right?
You won't be calling. The Zookeeper manager will push a notification to you. There is
Uh,
some change.
okay. And
Okay.
Zookeeper client will always have that latest IP addresses.
Yes, I mean, why? Because the session is persistent. It is a long running connection. So at frequent intervals of time, the heartbeat is going to be emitted from the Zookeeper client that is running on each of these database servers machines.
Okay, so in that case, I can assume that we are not calling every time zookeeper. I mean, that extra hopping we are not doing.
Which is exactly the point of watches, the benefit that watches give you. Instead of a pull based architecture, it's a push based architecture, right?
Got it. Got it.
Cool.
Got
Any
it.
other question with
Uh,
respect to this?
I have some other question. I will ask those at the end of the lecture.
Cool. Sure, no problems. Awesome. I'll just mute you. Awesome. Fine, guys. I hope you've understood what we've discussed so far. Please give me a +1 if everyone is on the same page with respect to what we've discussed for Zookeeper. If yes, we can start out with our discussion on messaging queues, or let's say basically Kafka, and we'll start out with a problem statement first of all with respect to it. Right? Awesome. So Kafka basically, guys, happens to be a very important. I mean, at least the perception is very important that it's a very important architectural piece in a lot of designs. But let's first of all, actually, before getting into Kafka, let's try to see what is the problem that Kafka is helping us solve. Okay. Just a moment. Awesome. So, guys, let us say that there is a problem statement in front of you that, let's say you go to Flipkart application, okay, and in Flipkart, you, let us say, end up buying a product, okay. Now, let us say this is you as a client who just bought this product, okay, and then after you bought this product, there are a bunch of things that Flipkart needs to do, okay. What is the first thing? It needs to call the payment service to ensure that the payment happens. Even before the payment service, it will have to call the authentication service, that hey, this kind of a user wants to buy this product, whether we should be allowing them or not, because there are lots of fraud detection programs also that keep on running in systems like Flipkart, okay. After the payments is done, then there'll be some logistics service that will be called, right? Ki, hey, let's say I have bought, let's say, a chair. Now that chair needs to be delivered to my home, so there needs to be some logistics service as well, which needs to get access to this information that someone has bought this specific product, and I need to now take some actions on top of it. After the logistics service, there can be some review service as well, or let's call it like last mile service, wherein, let's say, the product was delivered properly or not, or if there's any problem, that needs to be called, which is going to render a product specific review page for me, right? Can you see that all of these things need to happen for a single event that was performed by me on the Flipkart website? What was that event? Buy. I just clicked on buy button and all of these things had to happen. Correct? Now, what is the brute force way for you to do this? First of all, have you understood the scenario that I'm trying to explain? That as soon as you click on buy button, there are so many series of steps that need to happen with just this one event. Is this scenario clear to everyone? Please give me a +1 if this thing makes sense. Can I get a +1, guys? If this makes sense to you, can't see +1s. Is the problem statement first of all clear to you? That each of these people have to take some action after the buy button has been pressed, right? What is the brute force way of doing this? Call each and success after each call, execute everything in single go. So yeah, someone is saying execute all of these things in single go. So what you can do, you can say once this event happened, let me go ahead and send this event to the authentication service, right? So this is, let's say, the client. By client, I don't mean the actual person like me or you who is buying the products, but let's say the client application, Flipkart client application, the web app or the Android client, it is going to call the authentication service, right? It is going to call the authentication service. And then the client is also then going to invoke the payment service as well, right? Hey, we need to do some payments now. And then it needs to also call the logistics service that, hey, falana dimkana thing needs to be delivered to this specific user, go ahead and deliver it. Now, after that, the review service will be called, right? Some entity needs to call all of these services. What if this event, this service that was actually supposed to process this event, okay, while it was processing it, let's say this crashed. let us say the authentication service, while it was functioning, let us say it crashed. So can you understand that the client will have to re-deliver this event? Is this point clear to you? That while the authentication service was processing this event, and let us say did not have it cached or stored anywhere, in that case, the client will have to re-deliver the same event again. Please give me a +1 if this point makes sense to you. Is this point making sense, guys? Right? So, and I hope you can understand that the same event that was delivered to the authentication service, the same event needs to be delivered to the payment service as well. There is no difference between the event that was sent to the authentication service and to the payment service. Both of these events are same. So can you see that I am going to be sending a request with, let us say, data as 123 to authentication service and to the payment service as well. Can you see that the same piece of event, the same event message, let us say the message has a bunch of fields. Let's say 1 2 3 4 5 6. Let us say these 6 fields exist. Some, let's say 3 4 of these fields are going to be used by authentication service. 3 4 fields are, let us say, going to be used by payment service. Let's say 2 3 fields are going to be used by the logistics service now. Let us say 2 3 fields are going to be used by the review service now. Right? Can you see that I'm sending the same repetitive payload again and again to all of these services? And if any one of these services was to fail, then I will have to keep on retrying sending this message, right? And how will I even know that this service has actually failed? I will have to keep a track whether this service successfully processed this request or not. So so my request as a client is not just to send this request, but also make sure that this payment service has actually processed the request successfully. Correct? Are you able to understand that this client is going to have to do all of these things apart from just sending the request? Number one, it will have to make sure that if one of the services actually fails, in that case, it re-delivers that message. Number one. Number two, it is going to be delivering the same event to all of these services, because these are individual services. Whether authentication services successfully process it or not, the payment service can start functioning. Right? So these are independent things which are processing the same event, but they're having to do it with us from the same client. So this client has a lot of responsibilities. It needs to first of all figure out whether it needs to retry the event. It then needs to figure out whether event was processed successfully or not. Was processed successfully or not. It also has to send the same message, the same event to all the services. Tomorrow, if there was a new service that was, let's say, getting onboarded, let's call it a new service, then it will have to send request to this new service as well. So can you see that anytime a new service is being added or something that gets happened on the service front, which is consuming this event, you also have to make some code changes to your client side of the code as well. Is this part clear to you, everyone? That anytime some person who is consuming these events, let's say these services are consumers of an event, anytime some change is happening for the consumers of an event, you have to make some code changes on the producer of that event as well. Is this point clear to everyone? Please give me a +1 if this thing makes sense to you. If this does not make sense to you, write a no. I will explain it again. Anytime there is some change that is happening on the consumers of this event, what are those changes? Yeah, I'm explaining it again. So what are the changes that can happen on the consumer side? What if one of these services actually fails? So if it fails, you need to add some logic on the side of producers of these events that, hey, this event was not successfully processed by this specific service which was consuming it, and I need to re-deliver it. So for handling the failure, I need to add some change to the producer logic. Now, let us say there was a new service that was added over here. So just so that I'm able to send this request to this new service, I have to make some changes to the producer service for this event. Correct? So can you see that there is no separation of concerns over here? Some of you may have studied it in the LLD module. Some of you who have not studied it, you have common sense. You can figure out that in software, when you want to, let's say, add a feature to one class, you try to design it in some way that another class does not get affected. Or if it gets affected, there are minimal changes that have to be done over there. Right? I hope each one of you knows this is called a separation of concern. or you can call it single responsibility principle. Is everyone on the same page with me with respect to these two technologies? That these two design patterns are being violated when any change that has to be performed on the consumer side of things, you're also having to do it on the producer side of the things, right? I hope everyone is clear with the problem that is being presented over here. I hope everyone is clear with the problem, right? Also, the producer of this event, what is the responsibility of the producer of the event? It is just to produce that event, to just say that, hey, all these people who want to, let's say, play around with this event, go ahead and play with it. I'm not going to wait for you to do it, right? So the producer of the event should be ideally asynchronous. It shouldn't be synchronous. You producer of the event service should not wait. Okay, fine. The one of the consumer, let's say this service has succeeded. Okay, fine. I'm waiting for the response. All right, fine. Has this service succeeded? Okay, fine. I'm waiting for this response. Okay, fine. Has this service succeeded? Okay, fine. I'm waiting for this response. This is a very bad behavior, because the responsibility of the producer of this event service was to just fire and forget. This statement is very common in software architectures, that fire and forget. But this design principle is being violated when your producer service has to wait on all of these consumers just to ensure that this event has been successfully processed by everyone, right? So in order to solve this problem, in order to solve this technological problem, there was a design principle that was invented by some person, which is called as publisher subscriber pattern, right? And what is the data structure with which you can carry out this publisher subscriber kind of a data problem? You can use any sort of a queuing data structure. You can use any sort of a queuing data structure. What is a good quality of a queue? What is the typical quality? Why can't I use a stack over here? Why won't I use a stack over here? What is the quality of a queue that differentiates it from other data structures? FIFO, right? First in, first out. So if let us say I am going on to bookmyshow.com, okay? If I go to bookmyshow.com first, and then let us say my friend goes, let's say F1 is me and let's say F2 is my friend. If I go to bookmyshow.com first, my request should be processed first, and only after that the friend 2's request should be handled, if there is a dearth of the number of seats that one cinema can basically offer to for a film show, right? So in many of the cases, the event processing, ordering is very important, okay? And when event processing ordering is very important, and when the ordering happens to be something like a FIFO model, in that case queue data structure can help you a lot, because writes in queue are extremely efficient. It is O of one kind of a write. You just have to append something towards the end, towards the beginning, and in order to read it, you have to just read it from the end of it. If let's say this is a queue, you just write to the beginning and you read from the start. So in order to solve for this pub sub pattern, some people call publisher subscriber pattern as a pub sub pattern. People said that, hey, let us use a queue for this problem, but instead of using an in-memory queue, and there are so many flaws of using an in-memory queue, there is less memory available, memory is volatile, data can get lost, you have less memory, is costly, so you can only store so many events in an in-memory queue. Let us go ahead and invent something that is going to be persistent in nature. That is called as a persistent queue. Queue, why queue? I've already explained. What is the meaning of persistent? That means durable. Anything that you store in this queue is going to be persisted to the disk, and disk is a durable way to store data, which is how the entire motivation behind inventing a technology which can help you separate the producers from the consumers was basically that is something that came into picture, right? You have some producers and you have some consumers, right? Producers are the people who are launching an event, who are just throwing an event that, hey, go ahead and do this. For example, the type ahead case search system that we took, that the database that was batching the writes, instead of batching, it could have also just sent it in a queue. It could have, I'm not saying that is the ideal way, it could have just sent those writes in a queue, and the consumer at their own pace could have read those events. Those were pushed into this queue. And because of this, the producer can push events into the queue at a speed, let's call it 10 MB per second. And there can be consumers who can process these events at, let's say, 2 MB per second. So your producer need not be dependent on the speed of processing by the consumer, because you as a producer, you just wrote that event into this queue, and now you're unblocked. You're telling the consumer, hey, go ahead and process this event as whenever you want, as and when you want to do, right? This entire architecture is extremely asynchronous in nature. What do I mean by asynchronous? I used to get confused a lot when I read asynchronous thing for the first time. Can you guys give me a +1 if any one of you who's present on this call is not sure what the meaning of asynchronous is? Right? Okay, you're not clear. Okay, fine. Let me explain. So asynchronous basically means that, let us say I do an operation. Let's say I do an operation. Step 0 is, let's say I do an operation. And what is the operation? Operation is, let us say that, hey, let's take an example, guys. Okay, let's take an example. So let us say you're let's say a stonesmith, sorry. Let's say you're a stonesmith, and your only job is to collect all the stones or the bricks that are present in this pile, and you have to send it to some friend of yours who is then going to do construction with it. Okay. So what is a synchronous way of actually doing this? The synchronous way of doing this is that you pick one stone, you give it to your friend, and then the friend uses that stone in construction activities. Only after the friend has successfully used it in their construction activity, only then you actually go back and then you bring another stone for them. Then the friend is going to use the second stone for their construction activity. Once they are done with the construction activity, only then do you move back to this pile of stones and you take the third stone, and then you say, hey, I brought the third stone, and so on and so forth. So over here, you're doing an operation in a synchronous way. You are being blocked. By the consumer of the rocks that you are bringing. So in this case, the producer of these events is blocked on the completion of the process of this event that you carried all the way to them. What is that event? Basically the stone that you are carrying to your friend, who is going to then carry out the construction. And once the construction is done, they then tell you that, hey, this is done, now bring me another stone. Instead of this, what if we developed a solution this way, that let us say you are here, and let us say there is a let's say some storage container over here. In this storage container, your responsibility was to pick the stones from this pile and to just throw it into this pile. You just kept on throwing, and your friend, on the other hand, was taking the stone and processing it at his own speed. Your friend was taking the stone and doing the construction at his own speed, and you as a producer were not blocked by them. What did you do? I am just going to put this stone over here, and I'm going to now start putting another stone over here. So I am able to do my job, which is to take these stones from this entire cart and throw it into this place so that the other friend can use it. I am not getting blocked, and now I can go ahead and do some other stuff as well. Why? Because this friend too has so many stones in this storage structure that they don't need me to actively come and send this something. So they can do something on their own pace, right? So anywhere, when the producer and the consumer are not blocked by the successful completion of any one of their operations, in that case, you call that entire processing as asynchronous. When producer production event is not something over which the consumers consumption event is dependent on. Right? The consumer, for example, in this case, right? This person can keep taking the stones one day at a time, but this person can push 1,000 stones in one day. And then they can take care of another activity as well. Does this point make sense to you? What is the meaning of asynchronicity? You are not blocked on the successful processing of a specific event. Right? In the synchronous approach, however, you are blocked by the consumer to have processed that event successfully. Is this point clear to everyone who did not know about the concept of asynchronicity? Can I assume everyone now understands the concept of asynchronicity? Awesome. Thank you very much. Okay. So now in this, basically, there are two concepts associated with it, like two terminologies rather. One is the concept of publish, one is the concept of subscribe. Right? Publish basically means that anything that is being produced as an event, you go ahead and you enqueue it into this persistent queue data structure. That is the process of publishing something. Subscribe basically means that, hey, and I am going to take or consume all the changes that have been pushed into this specific queue. The same example as the stone person. The stone person will say, hey, any change that has happened into this warehouse where these stones are being pushed, I want to get that. So what am I going to do? I'm going to again poll, let us say. I'm going to subscribe, and I'm going to say that, hey, any changes that happen on this specific data warehouse where these stones are being thrown, let me get access to it. Then that entity which is doing this is basically called the subscriber of those changes. So this is basically the fundamental of a pub sub pattern. So anytime in any software architecture that you're designing, if you come across a situation where the rate of production can be different than the rate of consumption, I'm again repeating it, the rate of production happens to be not equal to the rate of production. Rate of consumption, rate of consumption. In that case, using an asynchronous architecture is very helpful. It is extremely helpful because now you can just focus on production activities. You're not blocked on the consumption of these activities. And this is exactly in contrast with the request response model, which we have discussed, which we have always been discussing so far. For example, if you fire an HTTP GET request, you send a request and you immediately get a response. Your client, the HTTP client that is running over here, it is not unblocked right now. It is going to wait to get the response for the request that you sent to your server. Whereas over here, you just published an event into this queue and immediately you are unblocked. So now you can do so many other things. Got it. But the events need to be processed in a sequence, right? Pranav, it depends on your use case. If your problem statement demands sequential processing, then yes. If it does not, it's not really useful. So Pranav, in the case of in the Flipkart use case, I mentioned that it is going to be the scenario that I took. It was supposed to be something that was sequential. But let us take an example where it is not sequential. Right? Let's say you went ahead, you clicked on the buy button, right? And after buying button, let us say your entire purchase has been done. Let us say the entire purchase has been done. This event was there in the queue, and the authorization, logistics, payments, everything has been done. Now, after a purchase is done, can you guys appreciate the fact that each of these companies, big companies like Flipkart, Amazon and whatnot, they end up doing a lot of analytics purposes. They end up using your event for a lot of analytical use cases to figure out some data science use cases. So there can be some data science service. There can be some ML model which can go ahead and use this event for enhancing its entire internal stuff. There can also be some analytics database which is going to be used by, let us say, some product managers in your company. And all of these things can independently happen for the same event that you ended up sending. Does this point make sense to you, Pranav, that these activities can happen independently, right? They're absolutely independent of each other, but they're only dependent on the same event. In this case, pub sub pattern makes a lot of sense. Shekina is saying, although HTTP request response are asynchronous call, it actually happens synchronously. No, so HTTP, when you send a request, you have to get a response. Unless you get the response, your HTTP client is blocked, at least for that request, right? So you need to get that response. That is a synchronous way of communication. This is the exact mistake that I once did in one of my interviews. I mentioned it last time as well, right? If you have some kind of a requirement where you do not want this asynchronicity. For example, if you're, let's say, logging into a system, let's say you're just doing logging into a system, would you follow a request response model, or would you follow a message queue kind of an architecture? What do you think? What do you think intuitively will be a more helpful? What do you think? Yes, it should be a request response model, right? Because it's a lightweight operation, extremely lightweight operation, and my logging in need not be, I mean, it is, I mean, okay, fine, you can say that, hey, there can be some analytics processes that can run on my on my logging into the system as well, but my immediate operation by which I can be immediately unblocked, the client can be immediately unblocked, is a simple request response model. It's a very lightweight process, just typing your password, getting authenticated by the service, and you get logged into the system, right? So you can immediately get access to the logging into the system if you follow request response model. If you were to, let's say, follow the message queue pattern, you'll basically be pushing the message into the message queue, and then asynchronously someone will basically going ahead and reading it. It is not a good pattern. Message queue kind of architectures you typically end up using when the producers typically do not know at what rate this message is going to be read. It may be the same, can be more, can be less, and the producers don't really care about the immediate response from the consumers as well. In the logging into a system, you absolutely have to wait for getting the successful response. You can't say that, hey, the client is right now, let's say I entered my password and then I'm waiting for 10 minutes for the event to be processed successfully by a consumer. That is a very bad architecture. I should immediately know whether my password was correct or not. Does it make sense, Pranav, why message queue is not a good technology choice, or asynchronous architecture is not a good choice for the logging in operation that we just mentioned? Any short-lived or small operation that you have to carry out, you should not be using a message queue typically. Okay. And I mean, why I say typically in every sentence, because you can always have some cases in which you may end up requiring this kind of an architecture, right? This is all about trade-offs, and there are so many other factors also that come into picture when you have to design a system in real life. That is why any statement that you make in your interviews or in a company at any time, you should always start with generally speaking, or in general, or typically, or in most of the cases, right? Always leave some room for the person in front of you to come back with some corner cases saying that, hey, this is not how it should happen, right? Because it's extremely subjective. Awesome. So I believe you would have understood the requirement for a producer consumer kind of a pattern, right? There's another requirement of it as well, right? Which I just mentioned also, which is, let us say there are some producers who are writing these messages into a queue, right? And let us say there are a bunch of consumers. Let's call it C1, C2, C3, C4, C5, C6, right? Let us say all of them are reading message events from the same consumer. Now, how is the single responsibility principle being solved over here? If tomorrow a new service comes over here, let's call it C7, if it wants to process the same event, I do not need, as a producer, to make any code changes in my service. I have just fired it and forgetted it. I fired the event in a persistent queue. Persistent queue means that the event is going to be stored over there, and then a new consumer can then say, hey, I want to start using this new event. What if you want to build a new service in a company? A new team starts and a new service is being built, which needs to process the same events from 1 year back, which already a lot of other people have done. So what you can do, you can just subscribe. You can just subscribe to this specific event, which is present in a specific data structure. And you can say, hey, I just want to reprocess it again, a new service. So in this case, a persistent queue kind of a data structure is extremely helpful. Pranav is asking, once the event is consumed, is it removed from the queue? So Pranav, it depends on the technology which this queue is being used with. If you're talking about Kafka, then no, it does not get immediately cleaned up as soon as it gets processed from the queue. Right? Awesome. So is this motivation at least clear to everyone? Why we need something like a producer consumer kind of an architecture? If this is clear to you guys, in that case, I can start discussing a little bit about Kafka now. Awesome. It's clear, right? So it's 11:38. We'll take our discussions till 11:50, and anything that is left over after that, we'll discuss it in the next class. Okay. Just a second. All right. So now let's try to see one concept of topics. Okay. So let us say you are using one message queue, right? Let us say you are using this message queue after you press that buy button, the Flipkart example only, right? And you ended up basically having a bunch of things that you wanted to do, right? For example, one of the things can be generating an invoice. You could and after that purchase has been done, right, then you may be wanting to send a confirmation email that, hey, you have spent your money on so many things, and you it should go ahead and now just just notifying you that you've bought this product, right? And you may even want to send an Android notification. You may even want to send a notification to your customer that, hey, something of this sort has been bought. Correct? Now, it's possible that all of these invoice emails and invoicing, what is the event that you would want to see? Let's say a purchased event. Let us say there is an event which says purchased, and it has all the event information. All the JSON payload has the information about it, right? So these people can end up using the same event, right? What if, although there is, let us say, another event. Let us say you wanted to message the vendor. Let's say there is a new consumer which comes in, which says, hey, I want to message the vendor that, hey, go ahead and invoke the logistics services now, right? What if this message to the vendor thing, it actually requires some other piece of information than the event that is already stored over here? Then what will you have to do? You will basically have to create a new event over here about the delivery information, and you will have to push it as a new message over here. Let's call this event as delivery information, right? Because let us say the message the vendor service does not really take care about the purchased event order. Let us say it is not able to get all the details from this event. So let's say it needs access to a different event, because what all information the message vendor, whatever the information message vendor requires, let us say those are not present in this this purchase event. So let's say it is deriving this information from the delivery information event. Now, can you understand that if you were to push both these kinds of data structures inside the same queue, it is going to be slightly confusing for these consumers to say that, hey, the invoice message will have to see that, okay, fine, let me draw this. So any purchase event, let me draw it with color green. Any delivery information, let me draw it with the color blue. Okay, so now what will happen is there will be some events like this. There will be, let's say, some delivery information event. Then let us say there are a lot of purchased events. Then let us say there is a lot of delivery information. And then let us say again there is a lot of this purchased event. So what you're trying to do, you're trying to store two different types of events in same queue, right? And what is happening as a result of this? A blue consumer, which is only responsible to process the blue events, is going to disregard these green messages because it is of no use. See, you cannot do point reads. Can you understand this fact that in queue you have to read from the last only? Please give me a +1 if this thing makes sense to you. That in a queue data structure, you can only read from the last. You cannot do point queries. Hey, give me the data from this at this index. You cannot specify the exact index in a queue data structure. You end up reading in general from the end of it, right? So this blue one will have to reject this. And in that case, can you see that we are wasting the compute of this blue service in processing the wasteful events, right? Similarly, the green service will come in, and when it has to read this blue event, it will have to process it and then drop it. So think of it in like millions of queries. Let's say there are millions of events being pushed into this Kafka cluster, into this persistent queue. In that case, this service is going to be processing so many wasteful queries, right? Because of this, one of the solutions with which we can do this is to have some sort of a topic kind or some sort of a table kind of a data structure inside of this queue. Or you can go ahead and create multiple queues, as Amit is saying. But let us say we want to use the same cluster, this massive Kafka cluster that we have, and we just want to have difference in the information that we are storing, so that all the green events are stored in one part of the data structure. All the blue events are stored in one part of the data structure, right? To ensure that we are able to do this in MySQL, what is the abstraction that MySQL uses to club similar data together? Can you go ahead and write it in the chat section? What is the abstraction used by MySQL database to store similar kind of data together? Guys, am I audible? No, not group by table. Yeah, table, right? Table, column, whatever you call it, table. So if you have a users table, it will only have data for the users. It won't have data for the orders that they have purchased, or something like Amazon, let's say, is maintaining information for okay, fine. A users table, let us say, for Amazon website will be very different from users table for AWS. Why? Because there is separation in terms of what information you have stored in it, right? Similar to that, in the world of Kafka, people do not people didn't really create tables. They created something like tables only, but they called it topics. Okay, so within the same queue, I'm just drawing it in a slightly enlarged way. In the same queue, you can have multiple smaller queues. You can have multiple smaller queues inside this large queue, which is called as Kafka. Let's call this as Kafka. Let's cover that this is actually called as Kafka as well, right? And this is the entity, that is the queue. So Amit is asking, I'm aware about the queues, workers like SQS, RabbitMQ. Is Kafka same thing or different? In some ways it's similar and in some ways it is different, but at a high level it is exactly same, right? So what you have over here, you have multiple queues. And what are these individual queues? You basically have them as topics, right? These are different topics. So let's say this topic is topic 1, 2, 3. This topic is, let's say, 4, 5, 6. This topic is, let's say, 7, 8, 9. So now what you can do, let's say I draw this, let's say I'll highlight this in pink color, right? Let's say I highlight this in yellow color, and let us say I highlight this one in red color. So now a consumer, which is red in color, which is a red consumer, let us say, that can, instead of wasting its bandwidth to process events from these two topics, it can just process the events from this place, right? And a pink consumer can go ahead and process events only from this topic, because it is only interested in those kinds of topics. So can you see that we have optimized with this with the segregation, the throughput process, or the speed of processing of events by these consumer applications? Does this point make sense to you? Why we need topics in our this data structure in Kafka, in this queue, persistent queue data structure? Is there anyone who has not gotten the hunch behind it? Can you please give me a +1 if this point makes sense to you guys? Like why there is a requirement of queues in our Kafka data structure? Does it make sense to everyone? Okay, awesome. So far, if you have understood the concept of these queues, I want to spend some time. How much time do we have? Okay, we have only 4 minutes. Okay, fine. I wanted to actually discuss a little bit about the Kafka architecture, how it basically functions, but I think we can't cover it in 10 minutes. Let's start with the Kafka architecture, guys, in the next lecture itself, right? I believe it will be too much. Partition and all, we'll discuss those things like consumers, producers, consumer groups, how scalability works, right? We will discuss all of those things in the next lecture. Okay, so awesome. So guys, I just want to do a quick poll, guys. Just give me 1 second regarding basically the speed, complexity, and explanation for these classes. I want to just know whether it's better than previous classes or it's not better. Like, I just want to work on it, right? Not better. All right, fine. I've just launched a poll quickly, guys. Please let me know about this. It will basically help me for tuning the above lectures. Okay. And anyone who has any doubts, feel free to stay back. People who don't have any doubts, you can drop off from the call. I will just start the doubt session in a second. Give me a moment. Start the doubt session. All right, guys. First of all, I'll just answer the questions from the questions tab for now. Just a second. So Shree's saying it's far better than initial classes, but topics are huge and covering multiple things in one class. So Shree, if I look at it from multiple things that we're covering in the same class, if I don't cover a few things, then you will not understand the topics in the way they should be understood by you, right? Because understanding something at the superficial level, I can always complete all the things in just 1 or 2 hours. In fact, in 1.5 hours, I can complete all the things that are particularly part of the syllabus. But if you have to understand exactly at the depths of it, which is going to be helpful for you, then you typically have to take some segues and you have to explain it, right? So it is a trade-off. If you guys would want me to discuss things at a relatively superficial level, I'm fine with doing that as well. But if you want to understand things slightly at it in slightly depth, in those cases, some more discussions may be required, right? I mean, no. Extended classes will go. Oh, Shri, obviously, I cannot extend the classes beyond 3 hours thing, and other people also have other things to do. But yeah, we'll see if we can schedule some extra classes in case there's some topics that are being left. Right? Awesome. So let me first of all start addressing the questions from the question tab. Himanshu is asking. So let's say we add a database server to the cluster. Then how does that metadata of that gets created in Zookeeper? Database server to the cluster. Okay. How does Zookeeper recognize the newly added server per se? So Himanshu, uh, can I unmute you if you are here on the call and discuss this route? Okay, just a second. Can you raise your hand? I'm not able to see you. Okay, fine. You've raised your hand. Hey Himanshu, can you hear me?
Yeah.
Hey, hi Himanshu. Yeah, please tell me.
Yeah, so question was regarding the Zookeeper architecture itself. Like when we were keeping metadata about the servers and keeping all the files in the file system.
Yeah.
So let's suppose there is a newly added server to the cluster
ठीक है.
for which metadata would have to be added to the Zookeeper file system. So
Yeah.
in that case, I wanted to know how will that happen?
Okay.
Whether it
Okay.
is the same thing like a Zookeeper client will be added to that VM server and then it will again do the same thing.
Same thing.
Okay,
Was that
got
the question? Anything else also on this?
that's it.
You have another question as well. How a server becomes a master in the first place? Is it you only, Himanshu Chaudhary?
Yeah, that's me.
Okay. So yeah, this is also same. matlab, So see, let us say a master database was created. Okay.
Mhm.
I mean, let's say you don't even call it a master database. Okay. Initially, let's say it is a fresh company, fresh day, and you have
Mhm.
just started your database. There's no write on your
Yeah.
database, right? So let us say you created, let's call it DB1, okay, DB2, and DB3. Okay.
Mhm.
Now there are two possibilities. If let us say I'm managing all of these databases, right? And I know that the client writes are going to first of all happen on the DB1 machine, and DB2 and DB2 I have not even exposed in my DB proxy.
Mhm.
Okay. If I know this, I'm going to manually use the Zookeeper APIs, right?
Mhm.
Zookeeper client locally, and I'm going to create a master file so
Okay.
that the master in the Zookeeper data structure has the IP address of this machine. That is one way.
Okay.
Does it make sense?
That's
But let's say I'm not there as a database admin. I'm not there, and let me just mark it. Yeah. So let us say I'm the database. I'm not the database admin, and I don't want to do it manually. In that case, let us say neither of these databases has received a write so far.
Mhm.
Okay. So in that case, each of these databases will send the Zookeeper client will send a request all the way to the Zookeeper node that hey, go ahead and create a master file, and the Zookeeper manager, right? It will take only the first request that actually lands over there, and it will then create this file and it will reject the other two files. And these other two files will get to know that okay, fine, our requests have been rejected, and the Zookeeper client then needs to handle this logic over here in the database server itself that hey, now we are not becoming the masters, we have to become the slaves. So then they will send a request again so that they can be registered as slaves. So short answer is all of them will send parallel requests. Whichever request lands first, that request will be stored in the master file. Basically, the master file will be created, and the IP address of that machine will be stored.
got it.
Right? And there's case 3 also. I just recalled. Case 3 is, let us say some of these databases had some writes. Okay, let's say they had this database. This is basically the wall of it. Let's say it has 1, 2, 3, 4, 5 writes. Let's say this database had 2 writes. Let's say this database had 3 writes. Okay.
Mhm.
In this case, the databases need to do some sort of a gossip protocol amongst them and
Mhm.
figure out who is the leader, which is what they do when a master fails and a slave has to be promoted to become a master. Correct?
Mhm.
Now, that slave leader election will happen against among them. They will talk amongst each other and they will try to figure out, hey, which of you has the latest rights, right? And they will figure out, okay, fine, this database has the latest rights, and hence only this database will send a write request to the Zookeeper cluster that, hey, go ahead and create me as the master. Does it make sense?
It does. Just one more thing here. So, this gossip protocol that happens, like the communication between all these servers, that is not part of Zookeeper's responsibility. That
No,
is
no,
happening. Yeah,
no. That is not part of Zookeeper's responsibility. You have to write it as your own application code. So when I say application code, it means relevant to your business use case. So you have to write it.
got it.
Any other question, Himanshu?
That's it. Thank you.
Thank you. Sudhir had raised their hand. Sudhir, just a second, I'll unmute you. Hey, Sudhir. Hello.
Yeah, am I able to?
Oh wait, I'm sorry. I wait. Sudhir, you are unmuted. I can hear you. Can you say something?
Yeah, am I audible to you?
Yes.
So, Nikhil, and like we have been talking about the zookeeper, right? So, could you please grab the complete picture where the zookeeper will sit? And like, let's say start with the means
Okay.
load balancer.
Fine.
Load balancer
Yeah,
equal to
sure.
the app server.
Sure. So let us say this is the client. Okay. It is trying to, let us say, talk with the load balancer. What does the load balancer have? What is it? Why do we have a load balancer?
It will distribute the traffic to different app servers.
How will the load balancer know which all of the app servers exist in my fleet of machines, in my group of machines?
So that using the zookeeper only.
So initially, let us say you configured in your load balancer, so let's say some 4 IPs, that these are the 4 hosts. But what if a new app server comes in? So in that case, your load balancer logic, it needs to figure out that, hey, a new app server has joined my cluster, correct? So there needs to be some way, and your load balancer also needs to know that if I'm forwarding a request to one of these app servers, whether that app server is healthy or not, correct? Right? So all of this work, there is one way which you can do all of this work. One way is Zookeeper, correct?
Right.
So you can use a Zookeeper cluster here, which is going to manage the states for your application server. It's not just that Zookeeper cluster is used to elect the leader in a master slave MySQL database cluster architecture. No, that is a wrong understanding. Okay. Anywhere where you have to coordinate some metadata about the system, about some distributed system where there is more than one machine, Zookeeper can be amazing for that. So the load balancer can say, how does it know whether someone is healthy, whether someone becomes unhealthy, let us say, right? What can the load balancer do? It can create a watch. It can create a watch on all of the files for each of these application servers. And anytime that file gets deleted, the load balancer will immediately reconfigure itself and say, hey, this application server is no longer healthy and I'm not going to send the request to it. Does it make sense?
Yeah. So basically, you please go ahead.
Yeah, I was just completing that Zookeeper cluster. One use case I have shown you as an application server. Now, application servers, once they have to, let us say, talk with a database proxy in order to reverse proxy in order to communicate with the database shards. Over there, also the same problem is going to arise. How does a DB proxy know that this database shard is healthy or not? They'll again go to the same Zookeeper cluster. They'll consult it. They'll ask, hey, is this database shard healthy or not? If it is not, that file would have been deleted. Get a watch event, and then the DB proxy will remove that database shard from its the configuration logic, right? And all the things around the master slave thing as well. Those things will also happen in Zookeeper cluster only, right? So Zookeeper same Zookeeper cluster can be used for so many different things, because at the end of the day, Zookeeper cluster is giving you 2 features which are important. One, hardware, and 2, the watches, and obviously the file system way, the hierarchical file system way to organize your entire architecture. Right? So this is where it is useful in the grand picture. Does it make sense?
Okay. Yeah. So here one more question. So Zookeeper is a software, or it's like Zookeeper is a server? I mean, like just like load balancer is completely clear that is the server itself, and it will have some logic which will distribute the loadings, right? So distribute the traffic. So similar case, Zookeeper is a server or software?
Okay, wait. You made 2 sentences. I want to clear that. First
Yeah.
sentence you said whether Zookeeper is a server or a software. This was your statement one,
Right.
correct?
Right.
And
Right.
what was your second statement? That you understand that load balancer is a server. Is this what you mentioned?
Yeah. I'm like load
Okay.
balancer when comes into picture, mostly we can say that is server, and there
Okay,
will
fine.
have logic, right? Yeah.
So, okay, fine. So let me answer this question. First of all, let me tell you this statement is wrong. Okay.
Okay.
Load balancer is server.
Yeah.
This is not a correct understanding. Load balancer is a program. It is a program.
Mm-hmm.
It is a program
Mm-hmm.
that is running on a
On a
server.
server. Right.
These are like kg and liter. That kind of a comparison you are doing over here. Server is the machine. Server is the
Right.
machine.
Right.
Software is the binary that you are running on that machine.
Right.
So Zookeeper, when someone says, or Kafka, or Cassandra, or any one of these things, they mean the binary, the software.
Okay.
Okay. You end up running it on a VM, and then you call that VM as server.
Okay. Okay.
So Zookeeper is a software. You can right after this call or even during this call, you can go to GitHub. I don't think it is open source. Yeah, I think it is open source. You can go to GitHub. You can see Apache Zookeeper. Yeah, it is open source. Yeah, you can see the code base of Apache Zookeeper. If you build it, you build the binary. Go ahead and run it on a EC2 instance. Then our EC2 instance is a Zookeeper server for you.
Okay.
Any other doubt on
So
this?
here one. Yeah. So here one more thing. Now let's. Could you please scroll a little bit up?
Yeah, to which place?
Yeah, this one only. Yeah, this one only. So where the consistent hashing will come into picture here?
Oh, consistent hashing. Okay, what do we do in consistent hashing? We basically say that hey, there's a fleet of machines. Let us say some 4 machines, and some of these machines are going to be shards for different database rights depending on the key, the logic of the key. Right, you hash the key, and then you find out that okay, fine, it is going to land on this shard or not. Correct. So that logic is embedded in that logic should be embedded in this database proxy layer, because the database proxy layer is the layer that needs to have information as to if let us say there is a key that needs to be written, right? Let's say key is equal to 123. So database proxy will figure out okay 123 ka what is the hash, and because this is the hash, to which shard it is going to lie on. But before it decides that okay fine, it must be having some data structure that has let's say a set of int which has the shards alive or healthy shards alive. So then whatever is the hash of this key, it will try to map it to one of the shards from this set, the healthy shards alive. How does it compute this healthy shards alive? It computes it using the Zookeeper cluster.
Zookeeper. Okay. So basically, yeah, now that is making sense. This complete picture. So hashing would be inside the DB. Yeah, DB proxy. So DB proxy is something like one kind of server only, right? Which will take care of.
DB reverse proxy. Is it DB reverse proxy? So do you know the difference between proxy and reverse proxy?
Proxy and the reverse proxy comes before the server, and reverse proxy comes before the server, and proxy comes before the client.
Yeah, I mean, yeah, that is wait, just a second. I'll restart my pencil. Yeah, but that is correct. In proxy, you are trying to hide from the client. In the proxy, you are trying to hide from the server from where the client is coming. And in the reverse proxy, you're trying to hide from the client as to from which server your request is coming. Correct?
Yes.
So that is the difference between these two things. So DB proxy is responsible for mapping the key to a specific shard in your consistent hashing circle, right? But what are the shards that are actually healthy? How does it
that will be taken care by Zookeeper? Yeah.
DB proxy will have to set up the same watches, correct? Watches to find for the heartbeats. And how will the heartbeats answer this question? How will the heartbeats reach for these shards to the Zookeeper cluster? How will the heartbeats reach?
That you have already created the session, right? So through the session, heartbeat will reach to your
exactly. And there'll be a Zookeeper client which will be correct.
So Zookeeper client will be sitting inside all the shards, right? Master shards.
Correct. Not on the shards, not in the shard, but on the server where the shard is running, right? The VM, the virtual machine or the machine where the server is running. Over there, there'll be a program Zookeeper client also, which will be doing this.
Okay. So I think Now this completes the picture. So basically, one more thing. So Zookeeper is a program will be running in a different server. We are not going to keep inside the load balancer or inside the DB proxy, because Zookeeper, we are trying to using the Zookeeper, it will be like a grand, as you are saying, right, universal kind of thing. So my whole system, whether it is a load balancer, whether it is application server, whether it is DB proxy, starting up different database machines, each and everything will be interacting with the Zookeeper only, right?
Correct.
Hello?
So it is a different program. And by the way, let us say your application servers when they're interacting with your Zookeeper server, and it is getting a lot of load, because you can see, right, that it has to maintain so many sessions to get the heartbeats and all. What if the one Zookeeper server is not enough? Then you can obviously create one Zookeeper server for, let us say, cluster, one Zookeeper cluster for application servers, and another Zookeeper cluster for other parts of your application.
Right.
Not a hard requirement that one company should have only one Zookeeper cluster. That is not the requirement.
Okay. And most of the times you are saying watches. So watches, that is something like you are registering, all right, means already with the Zoo manager, right? So registering in the sense all the Zoo client, right? Client setting will be different starting machine, right? And like, so what creating the watch, basically you are just like in publisher subscribers are already registered to your publisher. So similar kind of things here we are also doing, right? Similar kind of analogy, I can say.
Correct.
Hello?
Yes. Oh, yes. I was just saying yes. Can
Okay.
you hear me?
Okay, then. Thank you. Yeah. Thank you,
Okay,
Nikhil.
awesome.
Thank you so much. Yeah, I can hear you.
Yeah. Well.
Thank you, Nikhil. Good night. Thanks a lot.
All right, man. Thank you very much. Pranav, if we don't use Zookeeper, we will need to implement the relevant logic in load balancer and DB proxy, right? So, Pranav, typically when you use what do you call it, this load balancer, let's say from AWS or something, right? They end up using this technology Zookeeper internally. They just don't tell you. But if you were to, let's say, build your own load balancer, then yes, you will have to implement the same logic in the load balancer and in the database reverse proxy as well. How system handles synchronization without Zookeeper. So Pranav, typically, so you have to then solve the same problem within by building it, by integrating it in the same software in your program itself, right? I mean, you cannot do it without this thing. Like someone needs to do the heart beating thing. Someone needs to tell you that, hey, something has changed in your entire cluster. Zookeeper happens to be one way. You can choose to do it in the brute force also, a dedicated machine approach, right? If you are using Zookeeper watch, then heartbeat is not even required, right? Zookeeper watch, no, they're two different things. Wait. Zookeeper heartbeats are sent over heartbeats are sent on session. Heartbeats are sent on session that is created, right? So let us say this is one Zookeeper client creates a session, and then your heartbeats are being sent, okay, to the server. All right, and the watch is just a one time event. A watch has, let's say, been set on a file 1.txt. Let us say I go ahead and I delete this file. So then you'll send a delete event to the Zookeeper client, which actually had created this watch on this specific Z node. So they are two different things. If you are using ZK watch is just for the server to let you know this file has been created or deleted. And you can use watch for other purposes as well. Delete just happens to be one use case. And it is with the heartbeat that the Zookeeper client is sending that the file is actually not being deleted, right? This file is not getting deleted because it is receiving all of these heartbeats. They do different things, I'd say. Okay, guys. Anyone else has any other questions? Guys, anyone has any questions? Please let me know. Please raise your hand. I'm happy to answer it by unmuting you. Yeah. Hey, Shubhabrata, I've unmuted you.
Yes. So this is not related to Zookeeper, but I have one question. Like when you're using tunable consistency, if we choose to w equals to 2 or 3, more than one basically, then how the write operation works? Is it like we have to create two different connection and write in the database?
Wait, what your question is? If let's say we choose w equal to 2, first of all, I hope you understand the meaning of w equal to 2, right?
Yes,
That
yes. So basically, two server we will write
minimum,
minimum
minimum,
two server. Yeah,
minimum two masters in the cluster
will
you have
write.
to have. Correct?
Yeah,
Okay.
correct.
Now, what is your question?
So my question is it like from data? I mean, from application layer, we have to create two different connection to write it.
Oh, okay. This is your question. Okay. How do I explain this? Do you know the concept of connection pooling?
Yeah, yeah.
Yeah. So you as a client are just going to perform a write to this. You will obviously first of all reach out to these alive connections that are already existing in
Correct.
this connection pool, right? And these connections are then going to be multiplexed for all of these different databases. And this is basically the database reverse proxy over here, right? And let us say there are 4 databases behind it. So it will just send a write to this connection pool. Connection pool will then use all of these alive connections to send a write to at least 2 places. And as soon as it receives a successful response from at least 2 machines, something like using like a, what do you call it? That what is this data structure called? Uh, I'm forgetting the data structure, but at least when you get 2 threads that have responded, right? As soon as you get successful response from them, you can just let the client know that hey, so and so thing has been done. So you don't have to create 2 connections yourself. You
Okay,
let
so my question is very simple. So if we are using some sort of Spring JP or kind of this kind of thing, so we do simply database. I mean the table.save kind of that, right? I mean repository.save. So I mean when we do that, it is DB reverse proxy's responsibility to write in the two different server. Is that it?
correct, yes, because you don't directly typically. Okay, I'm again I'm saying typically. Okay, I don't know exact architecture that you're talking about, the one that you're using, but typically you do not communicate. Your application logic does not communicate directly with the database. You always have a database reverse proxy layer in between, because you don't know whether this request that you're sending, whether that is going to be successfully served because this is healthy or not. And it is not your responsibility, it's not the application code's responsibility to retry if it was not healthy. You just send it to the database reverse proxy, and reverse
Okay.
proxy has the role of figuring out
Okay,
whether this.
and reverse proxy will know some sort of how reverse proxy will know that it has been written to different databases.
How will the reverse proxy know whether the data has been written to the database or not?
Correct, correct. I mean two different databases.
Databases. So that's what I'm saying. Na? It will send requests. So that is, I'm forgetting the data structure's name. Yaar. What was that data structure that if you have, let us say, at least 3 threads, if they come inside a specific part, um, Java, what was the name? Okay, let's forget that data structure. But since you fired the write request to, let us say, the database proxy, fired the write request to a bunch of databases. Okay, and it was waiting for distinct responses. In the response, you can just embed the ID of this thread pool. No, not thread pool. I'm forgetting the name here. But anyways, what I'm trying to say, Shubhabrata, I'm trying to say that in the response, you can embed the ID of the database. So once you get at least 2 distinct IDs, you can just say to the client that hey, I've received successful write response from at least 2 different places. Just get access to it.
Okay, so it will DB reverse proxy will wait for at least two different ID from.
Yes, 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 yes.
Okay.
Does it make sense?
Yes.
Okay. Any other question? You also had some question in the when I asked in the middle.
So Zookeeper question I already asked, right? I mean, if we are using the Zookeeper watches, I mean heartbeat. I mean, I got a little confused over there. Yeah, yeah, it's clear now.
Is it clear? Watches
Yes,
and sessions.
yes.
Okay. Awesome. No more doubts, Shubhrata?
No, no doubts. It's clear
Got it.
now.
All right. Pranav is asking, can you cover message queue versus message stream in next class? What exactly What is Kafka exactly? Yeah, I'll cover Kafka. I couldn't get to the Kafka architecture today. We'll cover that. Yes, streams and what is the other thing that you mentioned? Message queue versus message stream. Simply speaking, message queue is the data structure, and message stream is actually the content of that message. Right? It's just a marketing term. Stream. It's like a lot of data which has no starting and end point. Right? You just keep processing the data as it is arriving, which is what people call as streaming. And is streaming or messaging, it's the same thing. They're just marketing terms, kind of like some people call it as a streaming system or messaging system. Exactly the same things. You put some message into the persistent queue, and a consumer can go ahead and start consuming it one by one. Now you can call it streaming system, you can call it a messaging system, same thing. And we'll take a look at a little bit on what is meant by topics, consumers, consumer groups, right, and broker, a little bit on brokers, and replication, a little bit about replication, right. These 4 5 topics I'll cover once, after which you'll be confident at least with respect to Kafka. Okay. Any other questions, guys? Oh, Shubhabrata, sorry, I muted you. I thought
Yeah,
by
so
mistake here.
yeah, just recall it. I just written down. I forgot to ask. So Zookeeper is a so we are keep sending the heartbeat to Zookeeper, right? So Zookeeper can be a single point of failure as well, right?
Yeah, so I
What
didn't draw it that way, but yeah, typically when you have a Zookeeper cluster, you have like the same thing, replicas of Zookeeper as well.
Okay, so Zookeeper will internally will have master slave architecture kind of thing.
Yeah. It will have that. It will have that. In fact,
Okay.
Zookeeper does not exactly follow a master slave architecture. What it does is, let's say there are n machines in the Zookeeper cluster. Okay, let us say let's call it 1, 2, 3, 4. 4 is wrong. Let's call it 5. Right. So what it tries to ensure that at least, let's say n is the total number of machines. So n by 2, at least n by 2 machines should have written should have written the data successfully, right? So and n is typically supposed to be an odd number, because typically, let's say there are 5, so 5 by 2, you want at least 3 machines to have persisted that file system data that I was mentioning, right? All the heartbeat things and the creation of the file or the deletion of the file, right? Those things should have been done by at least 3 machines. Only then you say that the write operation to the Zookeeper is actually successful. So that is one way in which Zookeeper ends up replicating amongst all of its models. But as far as I remember, it does not use master slave. I can confirm it once again. But at least for the write operation, this is how it does it. It tries to ensure that the write succeeds across at least n by 2 machines, and only then. And then you would obviously have a question that who is then going to manage Zookeeper's, what do you call it?
Yeah,
Right? Someone would
right.
have.
I was.
Yeah, I mean, so but yeah, which is why so Kafka, and it's a very complex piece of technology. I don't completely understand it, which is why Kafka was previously using Zookeeper for a long period of time. Okay, but after 7 8 years, there was a 3 year project. There was a 3 year project to just migrate from Zookeeper to a system where we do not even require Zookeeper for Kafka, right? So and they end up using Raft consensus algorithm for this. It's a I am not very adept with respect to exact internals of it. I can share the document on it. If you can just Google KIP 500 Kafka KIP 500. If you just Google this thing, you'll be redirected to an article which explains how Kafka moved from Zookeeper to a Raft consensus based algorithm. But yeah, in general, Zookeepers are not a good system to manage in production. It's a hard system to manage in production, because now you have to take care of the Zookeeper's health as well. So that is something that Zookeeper does internally. To just answer at least a question, if you may be getting it in mind, Zookeeper does that itself. The master keeps track. You don't keep another Zookeeper for Zookeeper. But yeah, this is at least right.
Okay, so I mean, for interview perspective, I mean, if interviewer asks me, I mean, I have to answer like Zookeeper keeps another Zookeeper internally. I mean,
Oh, so okay, it's fine. So see, if interviewer asks you about Zookeeper, what would they ask you? They'll say, okay, fine. What is a Zookeeper? Let's say you mentioned ki I'm using a Zookeeper. You should just mention it is used for all the things that we discussed, right? That managing the metadata for the internal state and for configurations, etc. What if he says, what if Zookeeper becomes the single point of failure? Then you mention that
yeah,
Zookeeper may, the file system that we are persisting, we are not storing it on one machine only. We have a fleet of machines where we're going to be replicating that information. And whether it follows multi-master or master-slave architecture, I can confirm by the next class. But typically, we try to create an odd number of nodes for our Zookeeper cluster. And any write operation that is being performed to our Zookeeper cluster, we make sure that it succeeds on at least n by 2 number of machines in our Zookeeper cluster. And only after that has happened, we let the client know, we let the Zookeeper client know that, hey, your write is succeeded. So that way we have introducing redundancy in Zookeeper as well. So this is how you can go ahead and answer.
Okay. Yeah. So Zookeeper write typically happen, during that server failure, right? When the
heartbeat does not reach.
When not reached, then only the write operation happen. So
only
I
then,
can assume this.
Only then you should not say, because what if a session is being started by a Zookeeper client because a database server just came into the system. A new slave was introduced, let's say, or new shard, let's say, came.
Yeah.
In that case, also you'll have to perform writes. Correct?
Yeah, correct. Yes.
Yeah. So yeah, what was your question?
Yeah, that was the question. Hey, one more thing, Nikhil. So, last class, I think I mentioned about, the load balancer single point of failure scenario. So,
so now think logically. What we've discussed today, doesn't it solve the question that you asked?
Yeah, it's kind of. But still, I mean, for load balancer, there should be another load balancer. That's not a good idea, right?
Which is what I'm saying. Now, let's say there is one load balancer, right? But you want to manage the health of this load balancer, right? And what is a load balancer? It is basically at the end of the day some VM which is running the code. So you can have redundancy.
Correct.
You can have the same software running on more than one machine as well. If one of the machine just goes, because load balancer is an extremely lightweight, stateless cluster, right? It is not maintaining any state of its own. It just needs to forward the requests. IP table rule, simple. It just needs to forward the packets somewhere. So you can have more than one server. This is exactly how load balancers are actually built in real life as well. If you want to build your own load balancer, you can write you can write a simple program which, based on the request, you figure out from the HTTP headers that, okay, fine, I want to send it to machine 1. And now the same program you can run on multiple machines. That is it. And then this request that is coming onto the load balancer can be served by any one of these machines, which are internally the part of the load balancer fleet only. And how will their health be managed? By some orchestration system, which you can consider to be Zookeeper, or any system something like Zookeeper. This is exactly what Kubernetes also does in etcd, using etcd for all.
I didn't get this, but I mean, can you explain me from the user perspective? A user came.
From user's perspective, you don't care about these things. From user's perspective, there's only one IP address with which you are interacting. Okay.
Yes.
Let us say it is the whatever. Let's say this is one machine. Let's call it the master machine. Okay. Let's call it that way. Let's say it is a master machine. You're interacting with that. Okay. And how will you interact with the master machine? How will you interact with the master machine? There will be some DNS record. Correct? So the DNS record will say that let's master dot something and whatever is the IP address. Correct? So there will be some DNS server. Right. Your request will first of all go to, because you were trying to hit a master dot something. So then that IP request you will get, and then your request will go to this master machine, which is for your load balancer. Now, let us say there's a problem. This master machine is no longer alive. So now you need to change your DNS record for this master load balancer. Correct? How can that be done? You can have a watch in your DNS server for the same Zookeeper. Correct? As soon as you get an event that, hey, a master IP has been lost, your DNS record will know that, hey, I cannot send the request all the way to the same machine, and it can then notify these Zookeeper clients. These other machines running behind the load balancer. Let's call it the slave load balancer machines. It can notify them that, hey, go ahead and promote one of yourselves to become the load balancer for me. And as soon as it does that, it will create a master file. And since you already had a watch in the DNS server, you will also get the IP address for it, and then you can serve your customer that way.
But DNS server is handled by ICANN, right?
No.
ICANN is a source.
You can have your own DNS server as well, right? So I told you, right? DNS server has multiple hops from your laptop all the way to ICANN servers. There's so many hops. First of all, within your cache, it tries to look at. If it is not within your cache, then whatever is the resolver IP that you have set. Let us say it is hypothetically set to 8.8.8. it then sends to a DNS resolver. Correct? What if instead of sending it to
Right.
a Google's DNS resolver, you change this IP address to your own DNS resolver? Let's call it 1.2.3.4. So then it is going to, let us say, Shubhavrata's DNS server. Only if it is not served by this place, then your DNS server will then start sending it all the way to your ISPs, to the ISP server. Then from ISP, it will start sending to all those things, right? Root name server, TLD, etc., etc.
So here,
Yeah.
which DNS server the watch will be?
AWS load balancer, AWS load balancer's host name that you get, right, which you can use whenever you want to query a load balancer. Let's say AWS ka load balancer you're using. So the AWS load balancer will also have an AWS DNS server, and that DNS server internally, it will talk to some service discovery mechanism. I'm not saying it is going to be using Zookeeper only, but something like Zookeeper is going to be used.
Okay, got it. I mean, we can assume, but I mean, if we make an interviewer make understandable, then we can say it's AWS DNS server where we'll keep and watch. If there is any.
Yeah.
Okay, got it.
Because it is not at all illogical. This is exactly how, if you were to build a load balancer, this is exactly how you will build it. Right? Because your question is genuine. I mean, if you have a load balancer for a load balancer, then what is a load balancer for that load balancer?
Right? Yeah. Yeah, got it.
So this is how you take a pen and paper, scribble around, and just try to write down the entire architecture of a load balancer if you were to be building it from scratch. Wherever you are stuck in that, then we can discuss it. But I think what we have discussed today, right, that should be more than enough for you to figure out to design any load balancer kind of thing yourself.
Yeah. Now after this, Zookeeper thing, it's much more, construct. I mean, the whole architecture I can think of.
Yeah. Awesome. Any other question, Shubhavrata?
No, thank you.